Hello everyone, welcome to my channel WishInfinite. Till now we have learned Python. Now we are going to take a big jump. Today we are going to learn NumPy. All the things in one single video. By the end of this video you will understand why every AI and data science project uses NumPy. And before moving further, I would like to inform you that you can now support my YouTube channel, and for that you can go to my channel WishInfinite and then click onto this join button. You can select the desired option to become a channel member. You can unlock exclusive perks while helping the channel grow. Your support means a lot. And a big thank you to everyone who has taken channel membership. As a token of appreciation, members can see their YouTube profile pictures featured randomly on channel homepage here. Also, you can access this complete AI engineering course under playlist tab. Feel free to save it by clicking onto the save button for quick access in your YouTube playlist section. Now let's continue. So what is NumPy? NumPy stands for numerical Python. It is a Python library that provides a Python array object which is faster and more efficient than Python lists for mathematical operations. So think of it like this. Python is a great language, but it was not built specifically for math and numbers. NumPy fixes that. It gives us a special data structure called an array, which is like a Python list but much faster and more powerful for doing math. And into this AI engineering course, we would be using NumPy frequently. So why NumPy for AI specifically? So every image in your computer is stored as number. Every AI model works with number in a grid format. When you train a neural network, it is doing millions of math operations on numbers. NumPy is the tool that handles all of this efficiently. Without NumPy, AI with Python would be impossibly slow. Now that's enough about theory. Now let's see how to install NumPy and how to import and use it. NumPy is installed using this command, which is pip install NumPy. And after installing, we are going to import this NumPy. For that, we are going to use this import NumPy statement. So to install this NumPy, we can open any terminal. It can be CMD, PowerShell, Git Bash, or any other terminal. For now, I would be opening the Git Bash terminal from the VS Code. You can also directly open any of the terminal from your Windows, Mac or Linux machine. For now, let's go to VS Code and here let me open the terminal. For that, click onto this terminal, new terminal, and here our terminal got opened. Now to install the NumPy, we just need to provide the command, which is pip install NumPy. And we need to provide the command inside the terminal. I've opened the bash terminal. You can open any of the terminal here. Like here, you can open command prompt, PowerShell also. For now, let's use this git bash terminal only. And here let's provide this pip install and then NumPy. Like this, we can install any of the packages that we have already discussed. For now, let's install only this NumPy. Now hit enter. So it will install this NumPy globally. Once the NumPy is installed, we can use this NumPy into any of the project onto this machine. And now NumPy got installed. Now let's import NumPy and let's see how to use it. And for that, we are going to use notebook. Here I've already created this notebook, which is numpy _ tutorial.ipynb. So here I'm already considering that you have already watched my Python setup related videos. That how to install Python, how to install VS Code, how to use Jupyter Notebook inside VS Code. If you have not watched these setup related video, you can go to my Python course and watch those videos. I will provide link of setup related videos into the description, or you can click onto this I button at top right corner to access those videos. Now here we have our notebook. I've opened it. Now let's import NumPy. So for that, let me click onto this code cell. And here to import the NumPy, you just need to provide this import and then NumPy. And now directly you can use this NumPy dot and any other items of this NumPy. But here we would be using alias rather than using this full name. So for that, we can provide as and then np. It is not mandatory to use this alias, but this np is a universal standard used by every developer worldwide. But it is totally up to you. You can directly use NumPy or you can use any alias name like np1 or any other name. Now we have imported the NumPy. And as we have used this pip install NumPy, so for us the latest version of NumPy got installed, which is 2.4.4. Here into the log you can see it, or you can also see it with the help of one command. Let's print the version here quickly. For that I would be using this print function, and here we will provide np dot then __ version __. which is going to provide us version of this NumPy. Let me execute this code cell and see we have got the same version, which is 2.4.4. And now as we are going to use this notebook, we will not require this terminal. Let me close this. Let me add some commands for your future reference so that once I upload this code onto the Git repository, you will not get confused. Let me add this heading, which is installing and importing NumPy. And here I would be using Markdown to add headings. So before this code cell, I want to add this Markdown. So I will click here. And now let me provide this heading here. Now click onto this stop editing and your heading will get added. And here let me add some hashes so that it will look like heading. Click onto this edit and here let's provide 4 hashes. Then space and then click onto this stop editing. That's it. So see, it is appearing like heading. It is not related to NumPy, but just to make proper notes, I am adding these markdown headings. So later it would be easy for you to refer this particular code. And as I told you, NumPy gives us array. So how to create that array? Let me quickly create that array and then we would be seeing that why we should prefer NumPy over Python list. Hit enter here and here to create an array, we need to provide this np dot and here we need to use this array. So array and then opening and closing of round parenthesis and here we need to provide different items. For that we need to provide this opening and closing of square brackets and here we can provide different items or numbers which we want to save. Here let's save some numbers. So 1, 4, 6, 8, 9 or any numbers we can save here. Let me save it inside one variable. So arr is the variable name, then equals to. Now let me print value of this arr. So here let's provide this print and then opening and closing of round parenthesis arr. And now let's click onto this execute cell and see we have got one array of numbers, whatever the numbers which we have provided. We would be seeing about these arrays in more details in some time. But before that, the question is that why we are using NumPy array if we are already having Python lists. In the Python list also, we store items separated by comma. Here inside the array, you would not be able to see those separated commas, but it is storing different numbers separated by space. But both NumPy array and Python lists are storing items. So what are advantages of NumPy over Python lists? NumPy is much faster than Python lists because it stores data in the continuous memory. NumPy uses significantly less memory compared to Python lists for storing the same amount of numerical data. NumPy supports element-wise operations directly. For example, arr plus 10 adds 10 to every element, whereas with the list you need a loop. NumPy arrays can only hold one data type, which makes calculation faster and more predictable than Python lists, which allows mixed data types. Apart from that, NumPy provides hundreds of built-in mathematical functions like mean, standard, sqrt, which are not available with plain Python lists. NumPy natively supports multidimensional data like 2D matrices and 3D arrays, which are awkward and slow to handle with Python lists. So these are some of the advantages of NumPy over Python lists. You can go through these points again, read it out, and then you would be able to understand that why we are using NumPy if we are already having Python lists. We would be using all these things, 2D arrays, 3D arrays, all the mathematical functions, calculations, right? For now, these points are sufficient to understand that what is the advantages of NumPy over the Python lists. Now let's move further. Now that's more than enough theory. Now we would be doing everything practical. So now our next topic is NumPy arrays. A NumPy array is a great value of same data type. Unlike Python lists, arrays support fast mathematical operation on large amount of data. We just saw a glimpse that how to create a NumPy array. Let's revisit that and we would be doing more extra things there. For that, let's go to VS Code. And here first we will put this heading, which is NumPy arrays. Here click onto this markdown and put / space. Now let me add one new code cell. And here we have already imported this NumPy as np into this first code cell. And we have already executed it. So we need not to put this import statement for each code cell. So remember that we will have to execute it for the first time. After that, you need not to even execute it, right? So first time, whenever you are opening the notebook, just execute this particular code cell where you are having this import statement. After that, you will not have to use this statement into any of the code cell. Also, you will not have to re-execute it again. So now this part is done. Input NumPy as NP. After that, let's create a new array. So to create an array, we just saw that what we need to do. We need to provide this NP dot array and then opening and closing of round parenthesis. And here we need to provide square brackets. And then we can provide different numbers separated by commas. So let's provide 10, 20, 30, 40, 50 or any number you can save here. Let's save it inside one variable. So ARR1 is the variable name which I am giving. You can provide any variable name. Let me print this array. So print and then ARR1. Let's execute this code cell and see we are able to see this array. And when we are using this NumPy array, remember that you would not be getting any separator. In case of list, we get such commas, right? In case of array, every item is separated by space. And this array is one dimension. So in the single dimension, we are having multiple items. So by looking at this array without any separator, we got to know that this is an array. But with the code also, we can check it. For that, let's provide this print statement. And inside it, I will provide this type function. And then opening and closing of round parenthesis. And here let's provide this ARR1, which is our array, right? So I am putting this type function inside the print so that we are able to see the output. Now let's click on to this execute cell. And see, it is showing this numpy.ndArray. So it is printing type of this particular variable, which is numpy.ndArray. Now 1D or one dimension array is a single row. But in real life, think of an Excel sheet. Data has rows and columns. That is a 2D array. We create it by passing list of lists. So here we are just passing a list where we are providing different numbers separated by commas, right? So this list containing different numbers. But in case of 2D array, we would be having list of lists. Let's see that. For that, let me add one more new code cell. Let's click onto this code. Here I will put comment as 2D array. I'm just putting comment. I'm not adding markdown here because it is subsection under NumPy arrays only. So to create the 2D array, what we need to provide? We need to provide this NP, right? Which is alias of this NumPy, then dot, and then array is the function which we are going to use. So every time whatever the array we are going to create, it can be 1D, 2D, 3D. We are going to use this array. And after this array, we need to provide opening and closing of round parenthesis. And here we need to provide list of lists. So how to provide it? So to provide the list, what we need to do? We need to provide opening and closing of square brackets. And now inside it, rather than providing numbers directly, we would be providing different lists. So again, to provide the list inside the list, we need to provide these opening and closing of square brackets again. And inside it, we can provide different numbers. So let's provide three numbers here. 1, 2, 3. So this is our main list, right? And inside that, we have provided one more list. So this is one of the item for the main list. And like this, we can add multiple lists inside a list. And to provide multiple lists, what we need to do? We need to provide a comma. Again, opening and closing of square brackets. And here we can provide some numbers. Let's provide 4, 5, 6. And again, let's provide one more list. So comma and then opening and closing of square brackets. And then 7, 8, 9. Here you can provide any numbers. I'm just providing numbers from 1 to 9. And here let's save it inside one variable. I will give variable name as array2d. Any name you can give, it's up to you. It should be meaningful, that's it. Now let's print value of this 2D array. For that we need to provide this print, opening and closing of round parenthesis, and then this variable name which is array2d. Now let's click onto this execute cell and see we have got our 2D array. So first we are having this opening and closing of square brackets, and inside it we are having three arrays. First array, then second array, and this third array. And why we are calling this 2D array? Because it is having multiple rows. See, first row, second row, and third row, and multiple columns. First column, second column, third column. So that's what we have given. Like this, you can provide 5, 10, or n number of rows and n number of columns. When you would be handling real data, you would be able to see much larger data set. For now, we are just taking small examples only. So now we know what is one dimension array, where we are having single row with different items. And then we saw that what is 2D array. Here we are having multiple rows with multiple items. So you can say 2D array is collection of lists inside a list. And like 1D and 2D array, we also have 3D array. A 1D array is single array element, 2D array is like table with rows and columns, and 3D array is like multiple tables stacked together. Let's see how to create a 3D array quickly. Let's go to VS Code. Here let's add one more code cell. Let's provide a comment like 3D array. Now to create the 3D array, what you need to do? You need to provide this np dot array. What is this np? You already know, right? At the starting we have used this alias for the NumPy. So np dot array, and then opening and closing of round parenthesis, and here we need to provide a list. So for that, opening and closing of square brackets, and inside it is going to have multiple 2D arrays. You can understand it like this. Let me just quickly show that to you. So to create the 2D array, what we did, we provided opening and closing of square brackets, right, which is a list, and inside it we can provide multiple lists. So let's provide opening and closing of square brackets again, and then let's provide some numbers like 1, 2, and like this we will add one more list. So comma, then 3, 4. So what we did, we created a main list. Inside it we have put one 2D array. See, this one is 2D array. So opening and closing of square brackets like this, and inside it again we have put list. So this is a small list, right, inner list, where we have put two items, 1, 2, and again comma, we have put second list which is 3, 4. And like this we can put multiple 2D arrays inside a list. And like this again we can put one more 2D array. For that, after this first 2D array, let's provide comma, and then again we are going to put a 2D array. For that, opening and closing of square brackets, and inside these square brackets again we would be putting square brackets, and here we are going to put numbers. So let's put 5, 6. Like that again let's create one more list. So comma, opening and closing of square brackets, and then 7, 8. Now let me save it inside one variable. So arr 3d equals to, and now let's print value of this arr 3d, which is our 3-dimensional array. It should be arr 3d, any name you can give, right? It should be proper, meaningful. Now let's click onto this execute cell, and see, this time we have got 3-dimensional array. So first we are having this opening and closing of square brackets, and inside it we are having these 2D arrays. See, opening and closing of square brackets, and inside it is having multiple 1D array. See, 1, 2, again space 3, 4, and this is our one more 2D array. So in short, you can understand it like this. See, here we are having 1D array. And what is 2D array? So 2D array is collection of multiple 1D array. See, like this. This is one-dimensional array. This is second one-dimensional array. This is third one-dimensional array. And now what is 3D array? So 3D array is collection of multiple 2-dimensional array. So this is our main array, and inside it we are having this 2D array. See, this one. And this is our second 2D array. And each 2D array would be having multiple 1D array. Just to make it simple, you can understand it like this, but it's totally up to you. If you will do practice with multiple examples, you would be able to get it easily, that which one is 1-dimensional array, which one is 2-dimensional array, and which one is 3-dimensional array. So here you can consider one example of color image. So a color image is stored as a 3D NumPy array. So it has height, weight, and 3 channels like RGB, red, green, blue. Now we know how to create 1D array, 2D array, and 3D array. Now let's go to the next section, which is creating special arrays. So NumPy provides built-in functions to create arrays quickly without typing values manually. These are used constantly in AI to initialize weights, create as data, and build sequences. So here NumPy provides built-in functions to create arrays quickly without typing values manually. These functions are zeros, ones, arange, linspace, and random. These are used constantly in AI to initialize weights, create as data, and build sequences. Now let's see how to use them. Let's go to VS Code. Here let me add one more code cell. Now to use these functions, first we need to provide this np, which is alias of NumPy. Then we need to put dot, and here we can use those functions. So here first we want to use zeros. So let's provide zeros here, and then opening and closing of round parenthesis. And here we need to provide two arguments. One is row and second one is column. So let's say we want to create an array of zeros with 3 rows and 4 columns. So here we will provide 3 as the row, which is first argument, then comma, and after that we will provide 4 as the column, which is our second argument. Now we can execute this particular code cell. And remember, as we are using this NP, so this particular piece of code should get executed. So let's say if you are closing VS Code in between, or you have restarted the VS Code, so in that case you will have to execute this particular code cell, where you are having this import NumPy as NP. You can create a separate code cell for this import NumPy as NP. So every time whenever you are restarting VS Code or opening this particular file, you can execute this piece of code. That's it. And here we need to provide one argument, which is a tuple. And how to create a tuple? So for that we need to provide opening and closing of these round parentheses. So what is tuple? So tuple can store multiple items. How to create the tuple? What are different properties of tuple? That we have already seen. So if you have not watched my video related to the tuple, you can watch that video. I will provide link of that video into the description, or you can click onto this I button at top right corner to access that video. Now we have created this blank tuple. What is tuple? See, we have provided this opening and closing of round parentheses. So zeros is our function, and this first opening and closing of round parenthesis is for that particular function. And then that second opening and closing of round parenthesis is for tuple. And here we need to provide 2 items. So we need to provide number of rows and number of columns. So let's say we want to create an array of zeros. So there, for an example, we want to have 3 rows and 4 columns. So what we will do, we will provide 3 as the first item of this tuple, then comma, and then 4 as the second item of this particular tuple. And now we can click onto this execute. And remember, whenever you are reopening or restarting VS Code or reopening this particular file, you will have to execute this particular piece of code, which is import NumPy as NP. Otherwise, you will be getting an error. If you want, you can keep this particular line into separate cell. So every time, whenever you are restarting VS Code or just reopening this particular file, you will have to execute only this piece of code. Let me do that. Let's cut it. And let's create one more code cell onto the top. And let's provide this import NumPy as NP here. And here we can execute it. So every time you need not to execute it. First time only you will have to execute it whenever you are reopening the VS Code or reopening this particular file. Just wanted to be aware of it. If you are getting any error related to the NumPy or NP, so you will get to know that you need to execute this particular code cell. Now let's go to our latest code cell. And here let me save this particular array inside one variable. So let's give the variable name as arrz and then equals to any name you can give. I have given z for zeros. Okay. And now let's use print statement to print value of this particular array. So print and then opening and closing of round parenthesis. And here we can provide this arrz. Whatever the variable name you give here, you will have to provide the same name here to print it. Now let's click onto this execute cell. And see, we have got an 2D array where we are having 3 rows, right? So this is our 2D array, and inside it we are having inner arrays. So this is our first array, second array, and third array. So you understand it like this, right? We are having 3 rows. First row, second row, and third row, this one. And we are having 4 columns. So first column, second column, third column, and 4 column. So whatever the value which we will provide for the row and column, we would be getting same array here. So this is a 2D array which we have created because we have provided value of row and column. And here you would be able to see this dot, which is for the float, right? So these numbers which are here inside this array are float. So 0.0, right? So it is showing 0, then point. And remember, here we have provided rows and columns. That's why it is generating a 2D array. If we will just provide value of row, let's say I provide 3 here, and if I execute this particular code cell, it will be generating a 1D array with 3 values. For now, let me just generate a 2D array only. Let's click onto this execute cell. And like this, you can also generate a 3D array. In that case, you'll have to provide 3 items inside the tuple. So try providing third item inside this tuple and try to generate a 3D array. You would be able to see the output. So this is your assignment, that how to generate a 3D array using this zeros function. And what is this zeros means? So this zeros means we are generating an array where all the values will be 0. Similarly, we have one more function which is ones. Let's use that. Let me add one more new code cell. If you want, you can use the same code cell. And just to see proper output, I'm using different rows. And here we are going to use ones. So let me provide it as the command. So ones. And here we have used zeros. So let me use it as the command. Now let's use this ones. For that, we need to use this NumPy, which is np dot and then ones, ones, and then opening and closing of round parenthesis for this particular ones function. And now here we need to provide the argument, which is going to be the tuple like zeros. And here we can provide items inside the tuple. So again, let's generate a 2D array with 2 rows and 3 columns, right? It's up to you how many number of rows and columns you want to use. So first item of this tuple will be 2, which is number of rows, and then comma, and then second item, which is number of columns. So here let's provide 3. You can provide any numbers. And now let's save it inside one variable. So I will give the variable name is arro and then equals to any name you can give. I'm just appending first alphabet of the function name. And now let's use the print statement. So print and then arro, which is our array name. Now let's click onto the execute cell and see it generated a 2D array with 2 rows and 3 columns. And like this you can provide any numbers like 4 rows, 5 columns, right? So it's up to you. And here this once function means it is generating an array where each and every element of this array will be 1. And here we have provided 2 elements inside the tuple. If you want to generate a 1D array, you can provide just row number. And if you want to generate a 3D array, so you will have to provide 3 items. Now let's see the next function, which is full. Let's click onto this code cell. Let's add the command which is full. And now to use this function, we need to provide np.full. And now we need to provide 2 arguments. So till now we were providing just one argument, which was a tuple. Now we need to provide 2 arguments, where first argument would be a tuple and second argument would be a number. So first let me add this opening and closing of round parenthesis for this full function. And now first argument will be tuple. So let's provide opening and closing of round parenthesis. And here we need to provide number of rows and number of columns. What it is going to do, you will just see. So here let's provide number of rows as 4 and then comma and number of columns as 5. Now as I told, we need to provide 2 arguments. So first argument is tuple, which is having 2 items, rows and columns. Now to provide the second argument, we need to provide comma, and then we need to provide the number with which we want to generate an array. Let's say we want to generate an array where each and every element is 7. So we can provide 7 here. So here we were having direct function like zeros, ones. But let's say apart from that, we want to generate an array of any number like 9, 10 or 7. So we can provide that particular argument here. Now let's save it inside one variable. So arrf is the variable name I'm giving, then equals to, and let's use this print statement and then arrf. Here we are getting an error because I've given this double A here. Let me change it. So now our variable name is arrf and same we are printing. Now let's click onto this execute cell and see it generated an array where we are having 4 rows and 5 columns. 1, 2, 3, 4, 5. And here each and every element is a number. So we provided 7 here, so that's why it has generated an array where each element is 7, which is a number. Here you can provide float also. Let's say we provide 7.5. So it will generate an array of 7.5. And like this you can provide any number. And now let's use the next function to generate an array. For that, let me add one code cell and the function name is I. So let's say we want to generate an array where diagonal values are 1. So in that case, we can use this I function. How to use that? So for that, we need to provide this np.I and then opening and closing of round parenthesis. And here we just need to provide one argument. So let's provide 3 here. You can provide any number. So this 3 means we want to generate an array of 3 rows and 3 columns. So 3 by 3 array where each diagonal value will be 1. Let me save it inside one variable. So arre equals to, and let's print this particular value. So print and then arre. Now let's click onto this execute cell and see it created one array of 3 rows and 3 columns where each diagonal value is 1. So it's up to you if you are having any requirement to generate such type of an array. So you can use this I function. And here it is generating a 2D array, remember, because we have provided one number only, but it is taking this number as the row and as the column. So 3 rows and 3 columns where each diagonal value is 1. Apart from that, all other values will be 0. And here if this dot is appearing, so remember this 1 and 0 are float values and not number. Like this, there are multiple functions, right? We would not be able to see each and every function, but here we would be covering important function which can be useful for you. Now let's see the next function, which is arange. So it is very similar to the range function inside Python, which we use for lists. Using that, we can generate a list. Similarly, by using this arange function, we are going to generate an array. Arange means array range. Now let's add one more code cell. And here to use this arange function, we need to provide np dot and then this function name, which is arange. And let me copy this function name and let's provide it as the comment. I'm providing these comments so that you would be easily able to identify each and every section. And here opening and closing of round parenthesis after this arange function name. And here let's first provide two arguments. So first argument would be the starting point and second argument would be the end point or stop point. So let's say if I provide 1, 9. So now we are going to generate an array where it would be having values from 1 to 8. This 9 will not get included. So remember that the second argument which we are providing will not get included inside an array. So it will generate an array from 1 to 8. So you will be able to see 1, 2, 3, 4, 5, 6, 7, 8 and not 9. Let's save it inside one variable. You can also use this execute cell button, but there it would be showing array and then its value. Let me do that. See, it is showing it like this, array, which is a function, and then it is showing the array value. So see, opening and closing of square brackets and then 1, 2, 3, 4, 5, 6, 7, 8. So it is not showing the actual array, but this is how you generate an array, right? If you want to generate an array from 1 to 8, so you will have to provide np.array and then this list inside that particular array. But for now, let me use the print statement so you would be able to see the proper array without any separator. So let's save it inside one variable. So now let's give the variable name as arra and then equals to. Now let's use the print statement and then arra. Here it would be printing value of this array, where we should be able to see values from 1 to 8 and not 9. Let's click onto this execute cell and see we have got one array, which is a one-dimensional array, where we are having values from 1 to 8 and this 9 is not included. Right? I'm again repeating, this last value will not get included inside an array. So remember that. And now there can be one more use case. So let's say we want to generate an array after skipping one step. So after 1 we want to generate 3, then 5, then 7 till whatever the point we want to generate. So in that case, what you'll have to do? So in that case, you'll have to provide 3 arguments inside this arange array, where you would be having start point, stop point, and after that, the third argument would be the step, that how many steps we want to take. Let me use that. Let's give the variable name as arra2 and then equals to, and now np.arange and then opening and closing of round parenthesis. And here let's provide 0 as the starting point, then comma, then 20 as the ending point. And here we want to step as 2. So after 0, we will be getting 2. And after 2, we will be getting 4. And like this, it would be skipping one step and directly jumping on to the second step. Now let's print value of this array. So print and then arra2. Now let's click onto this execute cell. And see, this print generated value from 1 to 9 without skipping any value. Because we have not provided any step, so by default the step would be 1. So 1 by 1 it is increasing the number. But here for this one we have provided the starting point as 0, ending point as 20, where 20 is not included, and then we are stepping with the number 2. So after 0 it skipped 1 and directly jumped on to 2. After 2 it skipped 3 and jumped on to 4, right? So plus 2 is getting added, 4, 6, 8 and till 18 we have got, because here we have provided 20, so till 19 we would have got. But here as we have provided a step as 2, so after 18 it cannot print 19, right? So it is stopped on to 18 only, because 20 itself is not included, right? 20 means till 19. So this stop number will not get included. Now let's see the next function, which is linspace. Let's add one more code cell. And here again we need to provide np dot and then linspace, which is this one. Let me copy the same name to provide it as the comment at the top. So let's provide this hash and then linspace. And here we need to provide opening and closing of round parenthesis after linspace function name. And now here we need to provide 3 arguments. So the first 2 arguments would be starting point and the ending point. And the third one would be the number, that how many evenly spaced number we want to see. Let me show that practically to you so that you would be having more idea. So let's provide the initial number as 1, the ending number as 20. You can provide any starting and ending number. And now let's provide third argument as 5. So comma 5. Now let's click onto this execute cell. And now let's save it inside one variable. So arrl equals to any variable name you can give. And now let's use this print statement and then arrl or arrlin. That name also we can give. Here also we need to replace it. Now let's click onto this execute cell and see it generated value from 1 to 2 where we have got evenly spaced number. So after 1 we have got this 5.75. So between each number there would be a equal space. Between 1 and 5.7 we have a space of 4.75. Similarly between this 15.25 and 20 we have a gap of 4.75. So between each number the space is going to be the same. Remember that. And how many numbers got generated? So 5 numbers got generated because we have provided 5 here. If we provide 6 here, so it will generate 6 equally spaced number. Let's provide this 6 here. Let's click onto this execute cell. So see, this time it generated 1, 2, 3, 4, 5, 6 and each number will be evenly spaced. Now let's see the next concept, which is random. For that, let me add one more code cell and here let's provide this heading as random. Now let's see how to use this. Let's say we want to generate a 2D array of 3 rows and 3 columns and all the items inside the array will be random numbers between 0 to 1. So in that case, what we should do? So for that, we need to provide first np dot and then this random. If you will mouse over onto this, you would be able to see this random is a module. And after this random, again we need to provide this dot and then we need to provide the function. So the function is rand, R-A-N-D. And now we need to provide number of rows and columns. How to provide it? So for that, first we need to provide opening and closing of round parentheses for this rand, and here we just need to provide 2 arguments, rows and columns. So let's say we want to generate an array of 3 rows and 5 columns. So in that case we can provide 3 as the row value, then comma, and then 5 as the column value. And remember, here we are not providing tuple. Previously for zeros, ones, full, we have provided tuple inside it. But here for this rand function we are directly providing 2 arguments which are numbers. First number is row and the second number is column value. Now let's save it inside one variable. So the variable name I am giving as arr and then equals to. Any name you can give. I am just appending first alphabet of any function. And now let's use this print statement and then arr. Now let's click onto this execute cell and see we have got 2D array with 3 rows, see 1, 2 and 3 and 5 columns, see 1, 2, 3, 4 and 5. And here each and every element inside this particular array is a random number between 0 to 1. So this rand function is going to generate an array where all the values will be between 0 to 1. And here if you will notice that each and every element inside this array is float number, which is less than 1. But let's say we want to generate an array with the random numbers between 1 to 100 or 1 to 200. So in that case, what you will do? So for that, we are having one more function which is randint. How to use this randint function? Let's see that. Let's add code cell and here let me add this heading randint. Now let's use it. So for that we need to provide np, then random module, then again dot, and here the function name is randint. So rand and then int, and then opening and closing of round parentheses. And now here we need to provide 3 arguments. First will be the starting number, second will be the ending number because we want to generate an array between the starting number and the ending number. Let's provide 1 as the starting number, then comma and 100 as the ending number. So now it will generate an array where each element would be between 1 to 100. And now we need to provide third argument here where we need to provide the size. In case of rand, we directly provided the size by providing number of rows and columns. But here with this randint, till now we have not provided the size. We have just provided starting and ending point. We have just provided that with which number we want to generate an array. We wanted to generate an array between numbers 1 to 100. Now to provide the third argument, we need to provide a comma and after that we need to provide size. So to provide the size, first we will have to provide this argument name which is size and then equals to, and here we would be providing the size. So to provide the size, we need to provide a tuple where we would be adding 2 items. So first item will be number of rows. So let's provide 4 here, then comma, and then number of columns. Here let's provide 7. So it's up to you what kind of array you want to generate. That how many number of rows and columns should be there and what numbers should be there. So it will be taking numbers randomly between 1 to 100. Now let's save it inside one variable. So let's give the variable name as arr underscore ri, random int. Ri for random int I am giving, any name you can give, and then equals to. Now let's hit enter. Let's use this print statement and then this variable name, which is arr underscore array. It does not matter that what name you want to use, but it should be meaningful. Now let's click onto this execute cell and see it generated a 2D array where we are having 4 rows and 7 columns, and these elements which are there inside the array are having number between 1 to 100. Here if you want to provide 50, so in that case it will generate an array where all the elements will be between 1 to 50. Let's do that. See, after execution we are able to see this array where numbers are in between 1 to 50. And here we are providing size for the 2D array because we are providing rows and columns values. But here you can generate a 1D array or 3D array. So it's totally up to you. In case of 1D array, you'll have to just provide one value inside a tuple. In case of 3D array, you'll have to provide 3 values inside a tuple. For an example, let me just quickly generate a 3D array. So let me provide 2, 2, 2. Let's click onto this execute cell and see it is generating a 3D array now. For now, let me switch back to the 2D array so that it would be easy for you to understand this particular concept. Let me re-execute it again and see every time whenever I am clicking onto this execute cell, it will generate an array with the random numbers. So every time these values will get changed. So rather than typing each and every value one by one, if you want to generate an array with the random numbers, directly just use it, right? So it's up to you what kind of array you want to generate, and accordingly you can use that particular function. So if you have noticed, whenever I am clicking onto this execute cell, every time it is changing the number because these are random number and it can change, right? Here if you will provide 200, so it will generate an array between 1 to 200, but every time it would be changing these values. See, again it is changing the values. But now here we would be learning one more concept where these values will not get changed. And for that we would be using a function which is seed. So this seed function you would be using in combination with this random. Let's see how to use that. Let me add one more code cell and here let's provide the heading as seed. Now let's hit enter, and here to use the seed we need to provide this np dot random dot seed, and now opening and closing of round parenthesis, and here between the seed we can provide any number. What is the use of that number? I will explain it to you. For now, let's just provide any number. Let's provide 8 here. Now let's generate one random array. So to generate a random array, either you can use this randint or we can simply use this rand. We just want to generate a random array. So to generate a random array, what we need to do? We need to provide np dot random dot rand, and then opening and closing of round parenthesis, and then number of rows, comma, number of columns. Here let's provide 4, 7. Any number of rows and columns you can provide. Now let's save it inside one variable. Let's give the variable name as arrs and then equals to. Now let's print this value. So print and then arrs. Now let's click onto this execute cell and see it generated an array with 4 rows. See, first row, second row, third row and fourth row, and 7 columns. See, 1, 2, 3, 4, 5, 6, 7. So for each row we are having 7 columns. Now here ideally what should happen when we are using this rand or randint? It should generate a random numbers. See here, every time it is changing the value. But here what is the case? We are using this seed. Now let me click onto this execute cell. See, value of this particular array is not changing. So that is the use of the seed. So let's say if you are providing this particular code to someone and you want to provide same data set. So in that case, they can use this np.random.seed and that same number here. So every time you would be able to see same set of data. Again, I am clicking on to this execute cell. See, it is not changing this particular data. Let's say if I change this argument inside the seed. So let's provide 42 here. You can provide any number. Now let's click on to this execute cell and see, keep an eye onto this 2D array and see it changed the number because we have changed this particular value for this seed function. And now again if I will re-execute, so then it is not going to change this number. So what this seed is going to do? So in short, always you would be able to see same output with this seed function. But remember, you will have to use the same number here. If you will change the seed value, So in that case, next set of data will get generated first time, and every time after that, it is going to generate the same data. So consider it like this. So you are having a book where you are having millions of random numbers. So this seed is kind of a book. And now inside a book, there can be multiple pages. So this number which we are providing, consider that as the page number. So we are providing 42. So it is going to provide random numbers from that particular page only. So that's why it is providing same number every time. If you are providing 1 here, so it will be taking random numbers from the page 1. And every time it will be taking same random numbers. It may be a little tricky or new concept for you. So you can remember it with this example of books, right? So you are having book with millions and millions of numbers. And when you are providing these numbers to the seed function, so in that case, you are saying that every time take random numbers from this particular page number only. That's it. Still, if it is not clear, just let me know into the comment. I can give you or try to explain you with better example. But for now, this is the best example which I could get. And I hope it is clear for you. So whenever you want to generate a random number, always set a random seed in AI/ML projects. So your results are reproducible. If you share your code, others will get exact same result. Because in case of AI engineering, there can be the case we will require set of data. And we want to share that code with our colleague or our teammates. So in that case, we can provide this seed value. So in that case, whenever they will generate the random number, they will be getting same set of data. That's it. And now let's go to the next section, which is array properties. Every NumPy array has properties that describe it. Shape tells dimensions. Dtype tells the data type. Ndim tells number of dimensions. And size tells total number of elements. Let's see how to fetch these properties. Let's go to VS Code. And here let me add one section. So previously we have seen all the ways to create an array. And now this is a new section where we would be seeing array properties. So here let me add one markdown section. Here let's provide // space and then array properties. Let's click onto this stop editing. We have got our heading. Now let's generate a new array. For that, let's add one code cell. Let's generate one small 2D array. Right, I am taking example of 2D array so that it would be easy for you to understand concept of this rows and columns. In case of 1D array, you would only be having rows. But in case of 2D and 3D arrays, we have rows and columns. We can also take example of 3D arrays, but to make it simple, let's go with the 2D array. Now let's create a variable arr_prop. Then equals to any variable name you can give here before equals to, and after equals to we need to create an array. So to create an array, the basic method is np.array, right? At very first we saw this method. So np.array and then opening and closing of round parenthesis. And here to create a 2D array we need to provide opening and closing of square brackets. And here we can provide number of rows and columns. So let's provide our first row. So to provide our first row we need to provide opening and closing of square brackets. And here let's give values like 1, 2, 3. And like this you can provide a number of values inside one array, which will be number of columns. Now let's provide the second row. So to provide the second row we need to put a comma after first list. So this is our first list, which is our first row, right? Then comma, and after this comma hit enter. And it is not mandatory to hit enter, right? You can provide it into single line only, but just to visualize this 2D array where we are having multiple rows, I am hitting enter. Now here again let's provide this second list, which is opening and closing of square brackets, and here we can provide any numbers. Let's provide 4, 5, 6. So this is our first row and this is our second row, and here we are having 3 columns. See column number 1, 2 and 3. So now this is our array. To understand this array properties, you can create any array, you can use any of the function, you can use random function to generate a random array. It's up to you. For now we are using this np.array function to generate a 2D array. Now let's hit enter. And now let's fetch properties of this particular array, which is array prop. Any name you can give, as I told. Now let's get shape of this particular array. So for that we need to provide this print statement so that we are able to see the output. And here we need to provide this variable name, which is arr_prop. After that we need to provide dot, and then we need to provide shape. That's it. And remember, here we are not using np. We need to use this shape property onto this array. So we provided the array name dot and then this property name, which is shape. Now let's click onto this execute cell and see what is happening. What is shape? See, it generated 2, 3. So what is 2, 3? So here we are having 2 rows and 3 columns. So that's why shape of this array is 2, 3, where 2 is number of rows and 3 is number of columns. Now let's fetch the next property, which is ndim. For that, again I will be using this print statement and then this variable name, which is arr underscore prop dot and then ndim. And this ndim is going to give us dimension of NumPy array. So this is our NumPy array and we should be able to see dimension as 2 dimension. Why? Because we created a 2D array here. If you will create a 1D array, so in that case you will be seeing dimension as 1. If it is a 3D array, so in that case you would be able to see dimension as 3. Let me click onto this execute cell and see this dimension is appearing 2. This second print. This first print is for shape. Here if you want to provide some text, that also you can do with this print statement. Let's provide shape here as the string, then comma. Here let's provide dimension or dim. Right, just text I am providing so that we would be able to easily identify which output is for which property. Let's again click onto this execute cell and see shape is 2, 3 and dimension is 2D. Here you can provide any string, right? This is print function argument. It does not have any relation with array property. Now let's see the third property, which is size, which gives us number of items or number of elements inside array. So here we are having 6 elements, so we should be able to see 6. Let's provide this. So print, here let's give this first argument as size, as we are going to get size or size value. Anything you can give, right? It's up to you. If you want to put hyphen, so it would be more easy to understand. And then let's provide the second argument. So comma and then this array name, which is arr underscore prop dot and then this size is the property name. If you will mouse over here also, you would be able to see that this is a property. See, now again let's click on to execute cell and see this size value is appearing as 6. This is just a string. So whatever you will provide here, let's say if I provide dim hyphen space shape hyphen space, so that would be appearing with the print statement. See, and now let's see the next property, which is dtype. So for that, again let me use this print statement. Print I'm using just to show you the output, right? It is not necessary that you need to use this print statement. You can save this particular properties inside one variable and can use it anywhere. Just to show you the output, I'm using this print statement. Now here we are going to get data type. So let's provide data type here. Then second argument we need to provide. First argument is a string. Any string you can provide here, whatever you want to see here. Now the second argument for this print statement is the property which we want to generate, right? So here let's provide this variable name, which is arr underscore prop dot and then we need to provide dtype like this, which should be able to give us data type of this particular array. So whatever the elements which we are having here, they are having a data type, and the same thing we should be able to see. Now let's click onto this execute cell and see its data type is integer. It is showing it like this int64, which is for 64-bit integer. And now as here we are seeing about this array property, which is dtype or data type, let's cover about data type quickly. Let me add one more code cell for that. Here let's give heading as data type. And now here let's create one array. So let's give the variable name as a equals to and then np dot and then this array function and then opening and closing of round parenthesis. And here let's generate 1D array. You can also generate 2D array, but just to save the time and to make you understand this concept of data type, I'm creating 1D array. It's up to you. You can create 1D, 2D or 3D array. Now with this array, we need to provide opening and closing of square brackets. And here let's provide some numbers. Let's provide 1, 2, 3. So this is a 1D array where we are having 3 elements or 3 items. So now data type of this particular array will be int64 like this one, because here also we provided numbers. Let's see that quickly. So let's provide print and then a, which is array name dot dtype. Click onto this execute cell and see we have got int64. Similarly, let's create an array with the float values. Let's give the variable name as b equals to np dot array, and then opening and closing of round parenthesis, then opening and closing of square brackets, and let's provide some float numbers. So 1.5, comma 2.5, comma 3.5. So any float number you can give, right? Any number with decimal you can give here. So here all the items are of float type. But what is the d type for this particular array? Let's see that. Let's use this print and then b dot d type. Click onto this execute cell and see for this particular array the d type is float 64. Now let's see one more concept here. For that, let's create one more array. C equals to np dot array, or let me copy this particular line. So np dot array, and there we are providing this 1 2 3, which is a integer array. If we will print the d type, we would be able to see int 64, right? Same array I have picked. Now here I want to convert this particular array to float. So for that, what I can do? So for that, I can provide second argument for this array function. So first argument is this list where we are providing multiple numbers. After this list, we can put comma, and here we can provide d type, and then equals to, and then data type in which we want to convert this particular array. So let's provide float here. Now what will happen? The data type of this particular array will get changed. Let's print value of this c first. So print c. Let's click onto this execute cell. See, it is printing an array, but here you would be able to see this 1 dot, 2 dot, 3 dot, which are float numbers. And now if you will print this d type, so we should be able to see float here. See float 64, because we have provided d type as float. But there is one more way to convert numbers or integer into float. Let's see that, and I will show you that why that particular way is preferred. So for that, let's create one array with the name d equals to, and then np dot array, and then opening and closing of round parenthesis. Then we need to provide a list, and here we can provide any numbers. Let's provide 1 comma 2 comma 3, right? Same array I am providing, which is the integer array. Now here we need to provide the second argument after the list. So let's provide this comma, and here we need to provide d type equals to, and after equals to we need to provide data type, and here we would be putting np dot float 32. You cannot use this float 32 directly. We need to use this np dot float 32, which is getting provided by this numpy. Now let's first print value of this d. So print and then this d. Click onto this execute cell and see, it is printing an array where we are able to see float 1 dot, 2 dot, 3 dot, which is very similar to this, right? Where we have provided d type as float. There also we were able to see this 1 dot, 2 dot, 3 dot, and here also we are able to see this 1 dot, 2 dot, 3 dot, right? Whatever the number you provide. So what is the difference? So before that, first let me print d type of this d array. So d dot d type. D is the array name. Now let's click onto this execute cell and see its data type is appearing as float 32. So why we provided this np dot float 32 to convert this particular array into float 32 type when we are having this float already, which is giving us this d type as float 64. So here's the reason. In machine learning, float 32 is most common d type. It uses less memory than float 64, but is accurate enough for training models. PyTorch and TensorFlow both defaults to float 32. What is PyTorch? What is TensorFlow? You need not to be worried about it. These are machine learning framework. When we will be seeing machine learning, at that time we would be learning about it. For now, you need not to be worried about PyTorch or TensorFlow. Just remember the name. That's it. Now let's talk about the next concept, which is indexing and slicing. So indexing lets you access specific elements from an array using position. Slicing lets you extract range of elements. So now let's first see about indexing. So with the indexing, we are going to learn to access a specific element from array. We already know how to index Python list. NumPy works the same way for 1D array, but become more powerful for 2D array. Let's see the practical example. So for now, let's create one 1D array. Let's add one more code cell. And here to create an array, we need to provide a variable name arr equals to, and then np dot array function we are using, the same basic function which we are using till now. And then opening and closing of round parenthesis. And here let's provide one list. So opening and closing of square brackets. And here let's provide some number let's provide 10, 20, 30, 50, 100. Any numbers you can provide. Now here we want to access value of this particular array. Let me first print all the values. So print and then arr, which will give us all the values. But now we want to fetch one of the value or the specific value. So let's try to fetch this first value. So for that, what we will do, we will be using indexing. Here let me use this print statement to print the value, and here we will have to provide this array name, which is arr, and to provide the index, what we need to do, we need to provide opening and closing of square brackets, and in between we need to provide the index number. So what is index number? So for the array or the list, the index will start from the 0. So for this first element, index is 0. For the second element, index is 1, and like this it will keep on increasing by 1. So 0, 1, 2, 3, 4. And like this, if there would be n number of elements, the last index would be n minus 1 because it is starting from 0. Now let's provide 0 here, which is the index number for this first value, which is 10. So we should be able to see 10. Let me click onto this execute cell and see this 10 is getting printed. This is whole array which we are printing, and this is first number. Similarly, we can provide any index here. Let's provide 3 and see what we are getting. See, we have got 50. Why? Because for this 50, index is 3. 0, 1, 2, 3, right? At fourth position it is, and the index is 3. So we have got 50 here. Similarly, we can also provide negative index, which will start from the minus 1. So minus 1 is for the last element. Minus 2 is for second last. And like this, it will keep on going. So minus 1, minus 2, minus 3, minus 4, and minus 5. Let's see that. So let's provide this print statement here. And here let's provide this arr, opening and closing of square brackets. And let's provide minus 1, which should give us 100. Let's click onto this execute cell and see we have got 100. Let's say if I provide minus 2, I should be able to get 50. See, we have got 50. Minus 3 will give us 30. And like this, you can get any element. See, we have got 30. And like this, we can also get a specific part of an array. For that, what we need to do? Again, let's provide this print statement, opening and closing of round parenthesis, and then this array name, and then opening and closing of square brackets. And here we need to provide starting and ending index to get the specific part of the array. So here let's fetch this array from this 20 to 50. So in that case, what we will have to provide? So we will have to provide the starting index, which is 1, right? 0 for the 10, 1 for 20. So let's provide 1 here. And then we need to provide colon. And after colon, we need to provide the end index or stop index. So here, as we want to get from this 20 to 50, so for this 50, what is the index? So for this 50, index is 0, 1, 2, and 3, right? So 3 is the index for this 50. So here we need to provide 3 plus 1. So we need to provide 4 here, which is the index for this 100, but this end index will not get included. So that's why we need to provide 3 plus 1. If we will provide 3, this 50 will not get included. It will include till index 2, right? So remember that this start point will get included, but this end point will not get included. Till n minus 1 it is going to cover. Now let's click onto this execute cell and see we have got 20, 30 and 50 array, right? So we have got this sub array from this main array, which is concept of slicing, right? We have sliced part of an array. Now there is one more concept. Let's see that, and then I will tell you what happened. So here we need to provide this print and then array name and then opening and closing of square brackets, and here we need to provide double colon and then any number. Let's say we provide 2 here. So here it is going to generate an array for every second element. So starting point will be this 0th index, which is 10, and after that it is going to take every second element. So it will skip this 20 and then it will take 30. After 30 it will skip 50 and it will take the next value, which is 100. And like this, if there would be multiple and multiple values, it is going to take every second element. If you provide 3, it will take every third element, right? So it's up to you what number you want to provide here. Now let's click onto this execute cell and see we have got this 10, 30 and 100. So see 10 and then second element, which is 30 after skipping 20, and then again skipped 50, we have got 100. So like this, whenever you want to get such type of array where you want to get every second element or third element, So in that case, you can use this double colon and then the number. And here I am just simply saying this double colon, but it is kind of single colon. Here at the left hand side, we usually provide a starting index, and after colon we provide the ending index. And again we are providing colon, that we want to get every second element, right? So here let's say you want to take numbers from 1 to this 5th index, right? Which will be till 4th position, which is 100, right? For which the value is 100. And now if I click onto this execute cell, so we will be getting 20 and 50. Here we have not got 10 because we have provided a starting index as 1, which is 20. So like this you can play with it, right? For now I will just provide double colon so that we get every second element from this array. Here when we are not providing any number at the left and right hand side of this colon, which means we want to start from the 0 and we want to end at the last element. So that's why we are not providing anything, right? While fetching the value in this manner also, if you want to start from the 0 index, so you need not to compulsorily provide 0. You can just provide colon and then any index which is end index. You can play with it, just try it, just let me know if you are getting any confusion. There can be multiple permutation and combination for this slicing concept. You just try it and let me know if you are having any confusion. Here let me add heading also. I forgot to add the heading, where the heading is indexing and slicing. Let's paste it here. Let's provide // space. Save it. Now we have seen about indexing and slicing about 1D array. Now let's do the same for the 2D array. Let me add one more code cell. And here let's create one array. Let's give the array name as matrix. Equals to, you can give any name, right? 2D array is kind of matrix. So that's why we have provided matrix. Now here let's create one simple 2D array with 3 rows and 3 columns. So np.arrays and then opening and closing of round parenthesis and then opening and closing of square brackets, and here we are going to provide 3 rows and 3 columns. Let's provide the first row with the numbers 1, 2, 3. Again let's provide the second row with opening and closing of square brackets, and here let's provide 4, 5, 6. Let's provide the third row, so opening and closing of square brackets, and then 7, 8, 9. Now our 2D array is ready. I am taking very simple example. You can generate any array with the random number or any of the methods which we have seen. Now here let's try to fetch any specific element from this array, which is a 2D array. So for that what we need to do? We need to provide the array name, which is matrix, and then we need to provide the index number. And how to provide the index number here? So for that we need to provide opening and closing of square brackets, and here we need to provide the index number. So here for the 1D array we were directly providing the index number like 0, 1, 2, 3, right? Because the index were from 0, 1, 2, 3, right? They were getting increased. But in case of this 2D array, how will you provide indexing? So in such cases you need to provide row number and column number. So let's say we want to fetch this 3. So for that, what is row number? Row number is 0. Every time remember, whenever we are learning this concept of indexing, number will get started from 0. So for first row index is 0, for second row index is 1, for third row index is 2, and so on. So here let's provide 0, which is for the row number 1. Now we need to put comma, and after that we need to provide the column index. So what is column index for this 3? So see, for the first column the index is 0. For the second column index is 1. For the third column index is 2. So let's provide 2 here. So 0th row, which is our first row, and column at second index, which is our third column, right? Remember this n-1 concept, because indexing are starting from 0. That's it. So whatever the position they are at, its index will be position -1. Now here with this index we are going to get 3. Like 0th row and column at second index. So 0th row, which is this row, and here this column, right? So we have this 3 at this particular position. Let me use the print statement and then opening and closing of round parenthesis. Inside it we are putting this value. And here I have made this one mistake. Here we need to give this function name as array, not arrays. Now let's click onto this execute cell and see we have got 3. Similarly we can get 5 also. So for this 5, which row is there? So it is the second row, and for the second row index is 1. So here we need to provide 1. And for this 5, what is the column number? So column is second. And for the second column, what would be the index? Index would be 1. We need to provide 1, 1. Now let's click on to this execute cell and see we have got 5. Similarly, we can get 9 also. In case of 9, the index for this third row will be 2. So let's provide 2 here. And index for this column will also be 2 because it is third column. Now let's click on to this execute cell and see we have got 9. And like this, you can provide row and comma value, but just keep in mind you are providing the index number. So in that case, it will start from the 0. Or you can simply call it 0th row, first row, second row, or 0th column, second column, first column. So it would be more easy for you to remember. Rather than every time providing position -1, you can simply remember it like this. Let's access this 8 also. So in that case, again, we can provide this print and then matrix, which is our array name, and then opening and closing of round parenthesis. So in case of this 8, you guess what is the row and column value we need to provide. So here, this is the second row, right? 0, 1, 2. So we will provide 2, comma, and then 0th and first column. So 1. Now let's click on to this execute cell and see we have got 8 by using this second print. Now let's see how to get the entire array. Now here till now we are getting each and every element. But now I want to get an entire row. So in that case, what I'll have to do? So let's see that. For that, let's provide this print and then opening and closing of round parenthesis, our array name, which is matrix, and then opening and closing of square brackets. So let's say we want to get our first row. So for the first row, index is 0, right? We want to get 0th row, you can say. And then we want to get each and every column. So now what to do? We cannot directly provide the column number because we want to get each and every column. So for that, first put comma here and then you just provide this colon. Colon mean I told you, right? Before the colon, we need to put the starting index, and after the colon, we need to put the end index. But when we are not providing anything or when we are providing it blank, so in that case, it will automatically consider that we are providing starting index as 0 and ending index as the last position. Here the ending index would be 2, so we'll have to provide 3 because this 3 will not get included. Let me execute it. See, it printed 1, 2, 3, and as I told you, when we want to get everything from starting index to the ending index, so similarly we can leave it blank, right? So at the left hand side of the colon we were providing 0, so we removed it, and here at the right hand side we were going to provide the end index plus 1, so that also we are removing. So automatically it will consider that we want from the starting index to the end index whenever we are leaving it blank, right? So don't get confused if you are seeing this blank colon. Now let's click on to this execute cell and see there is no change because we have got the whole row when we remove the starting index and the ending index. Now similarly we can also get the entire column. Let's try to get this column, which is our second column, or if you will say in terms of index, so 0th column or the first column, right? Don't get confused with these numbering. So if you are using index to call row number or column number, start from the 0. If you are using position, start from the 1. That's it. But every time while providing it in terms of index, you need to start from the 0. So it's better you start calling on the basis of index rather than calling them with the position number. Now let's get this first column, which is 2, 5, 8. For that, we need to provide the sprint statement, opening and closing of round parenthesis. Here let's provide matrix and then opening and closing of square brackets. And here what we want to get whole column, and column index is 0 and 1. But we want to get each and every row item. For this column, we want to get 2 from the first row, we want to get 5 from the second row, we want to get 8 from the third row. So in that case, we can do the same thing. We can just provide colon here, which means from the starting index, which is 0 for the row, and the ending index. And here, as I told you, if we are providing blank colon and at the left and right hand side we are not providing the starting and ending position, so it will automatically consider that it need to start from the 0 and go till end of that particular array. After that, we need to provide comma here, and here we need to provide the column index. So the column index would be 1 for this particular 2, 5, 8 column. Now let's click on to this execute cell and see it printed 2, 5 and 8. So here we are able to slice a column, right? And here it is giving us a new array. We can save this particular value inside one variable and can use it anywhere. and here we sliced a whole row or whole column. We can also slice or get a submatrix. Let's say we just want to get 1, 2, 4, 5. So in that case, what we will have to do? Let's see that. Let's use this print statement only just to see the output quickly. And here let's use this matrix, which is our matrix or array name, and then opening and closing of square brackets. And here we need to provide row and column number. But we want to fetch this 1, 2, 4, 5, right? This submatrix, which is our 2 by 2 block. From very big matrix also you can fetch any submatrix. So here how we will provide this indexing. So what we want to do, we want to get these two rows. So this is our 0th row, this is our first row. So let's provide that. So what we need to do, we need to start from this 0th index for our row, colon, and then this first index, right? 0th row, first row. And then we want to go till this first row, 0th row and first row. So here we will have to provide the end index. And as I told you, every time you need to remember, whenever you are providing end index, you need to provide +1. Why? Because it will not include that particular value. So here we will provide 2 as the index, which is index for this row. So automatically it will get omitted, right? But remember, whenever you are providing the end index, you need to provide that index +1. So here index was 1 because we want to go till this particular point, and then 1 + 1 is 2. So now here we have provided the row part. And here, as I told you previously, that if we want to start from the 0th index, we can simply remove it. So automatically it will put 0 at this particular point. Now this row part is covered. Now we need to provide the column value. So for that we need to provide comma here, and here what you will provide. So we want to cover this particular column, which is column 0, and then column 1, which is this column. So we want to start from the 0th column, colon, and we want to go to this first column, right? 0th column, first column. So here if we want to go till this first column, so we will have to provide 1 + 1, right? And +1 we need to provide. So we will be providing 2. So before the colon, every time we need to provide the start value, and after the colon we need to provide the end value. So don't get confused with this comma and colon, right? So before the comma we are providing the row, and after the comma we are providing the column, right? And when we are using this colon, we are providing starting and ending index. And here again you need to remember, as I told you, that if we want to start from the 0th index, we can simply remove it. If we want to go till end of the index, so we can also remove that particular value, right? End value. We can simply provide this colon, but here we want to go till this particular point only, right? First column. So in that case we will be providing 2, right? 0th column, first column. When I am saying first column, which means I am calling them by index number. So now in that case, what should be the output now? We should be able to see a 2D array where it would be having 1, 2 into the first row and 4, 5 into the second row. Now let's click on to this execute cell and see we have got a 2D array where first row is having 1 and 2, second row is having 4 and 5. That's it. And like this you can get submatrix or slice subarray. So remember, when we are saying this colon, and at the left and right hand side we are not providing anything, which means give me everything from starting index till end index. Now here, as we are aware about indexing of an array, we can also see a concept of modifying an element of an array. Now let's see how to do that. Let me add one more code cell here. Here let me give the heading as modifying element. Now let's create 1D array. If you want, you can also create 2D or 3D array. But just to understand this concept, I am using this 1D array. So np.array, and then opening and closing of round parenthesis, and then opening and closing of square brackets. And here we need to provide some numbers. Let's provide 1, 2, 3, 4, 5. Now let's change any of the element of an array. Let's save it inside one variable. Let's give the variable name as arr. You can give any variable name. Now let's change value of this one, which is at 0th index. So for that we need to provide this array name arr, and then opening and closing of square brackets, and here we need to provide the index number which we want to modify. So here we want to modify value at this particular index 0. So we will provide 0 here, and then what new value we want to put here. So for that we need to provide this equals to, and here let's put 99. You can provide any number here which you want to change. So on place of 1 we should be able to see 99 now. Let's print value of this arr. So print opening and closing of round parenthesis and then arr. Now let's click onto this execute cell. And see, we have got 99 at the 0th index. Then 2, 3, 4, 5. Similarly, we can change value in bulk. Let's also do that. So at the 0th index, we have already put 99. But at the first and second index, we want to change it to 101 or 102. Any number you can pick. So for that, what you'll have to do? Again, we will have to use this indexing concept only. But when we want to hit multiple elements, we use that colon, if you remember. So again, let's provide this ARR, opening and closing of square brackets. And now we want to change values at the first index and at the second index. So for that, what we will have to provide? The starting index would be 1, then colon, and the ending index will be this index plus 1. So 0, 1, 2. For this 3, the index is 2. So here we would be providing this 3 because this particular index will not get included. Now here what we want to change. So here we want to put 109 here, or any number you can put. Let's put 109. Now let's click on to this execute cell. And see, we have got 99 here at the 0th index because we have put it here. And we have got 109 at the first index because we have provided this starting index as 1 and ending index as 3, which will get omitted. So that's why only first index and second index got modified. Now we learned how to modify 1D array. But now you will say how to modify 2D array. So in that case, again, you'll have to use the same indexing concept where you'll have to provide row and column. Let me just quickly do that. Let me take this same matrix, like I have copy pasted it. And now let's change value of this 5. So for that, you need to provide this matrix name or the array name and then square brackets. And here we need to provide the row and column. So here we want to take this 0th index row, first index row. So let's provide this 1 as the row number, which is a rows index. And then we want to change this 5 to 555. So for this, column index is 0th index and then first index. Let's provide 1 again here. So row at first index and column at first index, which will be this 5, right? 0, 1 and 0, 1. Now we need to provide this equals to, and let's provide 555 here. Let's print value of this matrix. So print opening and closing of round parenthesis and matrix. Now let's click onto this execute cell and see, we are getting this 2D array, but here on place of this 5, we are now getting 555. If you want to change values in bulk, so in that case, you can use this colon, right? You will have to provide row with the colon and column with the colon. Whatever the index which you want to provide as the starting and the ending index, that you can provide. So it is very simple concept, but you will have to do practice, right? So that you will be able to master this particular concept. And it is going to happen very frequently in case of AI engineering that you need to fetch a specific part of the array. It can be 1D array or 2D array, or you need to modify the specific part of the array. So you can play with it, try to make multiple permutation and combination and see what is happening. If you are getting any issue or any doubt, just let me know into the comment section below. Now let's discuss one more concept, which is Boolean indexing. Boolean indexing lets you filter array elements based on a condition. It returns only the elements where the condition is true. It is very useful for data cleaning. Let's see the practical example. Let's go to VS Code. Here, let's add code cell. And here, let me create one single one-dimensional array. So let's provide np.array. And here we would be providing some numbers within the list. So let's provide 5, 15, 25, 35, 45, 66, 99, 101, and like this you can put any values. After each comma we can put a space, so it will look more proper, right? It is not mandatory to provide the space, but it's better to provide it properly so that we would be able to see it easily. Now let's save it inside one variable. So arr underscore bool. Any variable name you can provide, as we are understanding the concept of Boolean indexing, so I am providing name like this. Let me add this heading also. Click onto this markdown and the heading would be Boolean indexing. This one, let me copy paste it. So double hash and then space Boolean indexing. Let's save it. So now let's say out of this array we want to get all the values which are above 30. So how you will get it? So in that case, what you need to do, you need to simply provide this array name, right? In this case, the array name is arr underscore bool. And then we need to provide opening and closing of square brackets. Here we are going to provide the Boolean indexing. Whenever we are providing any indexing to fetch or modify the value, we use these square brackets, right? Opening and closing of square brackets with the array name. Now in case of Boolean indexing, we do not provide numbers or this colon. So now what to provide here? So in case of Boolean indexing, we need to provide a condition. So here what is the condition? Here we want to fetch all the values which are greater than 30, which are 35, 45, 66, 99 and 101. So here the condition would be array name, which is arr underscore bool, and then greater than, and what is the condition? That we want to fetch all the values which are greater than 30 inside this particular array. So here let's provide 30 here. That's it. And now we should be able to get one array where it would be having all the values which are greater than 30. Now we can save it inside one variable, or we can directly put this particular expression inside the print statement. For now, let's save it inside one variable. Here let's give variable name as arr1 and then equals to. And now let's print the value of this arr1. If you want, you can directly put this particular expression here inside this print. Now let's click onto this execute cell and let's see the magic. And see, we have got this 35, 45, 66, 99, 101 and whatever the value which will be greater than 30, we would be able to fetch it. So we have created a sub array using the Boolean indexing, right? We were able to fetch all the values with the specific condition. And it is not necessary that these values should be into order. Let's say after 101, I am providing 9. But here we would not be able to see 9. Let's click onto this execute cell. See, there is no change because we have included this 9, but it is not greater than 30. So that's why it did not get included here. And like this, you can provide any condition to fetch the specific value. Now let's see one example where we want to fetch all the even numbers out of our array. For that, let's create one array. So arr2 equals to np.array, which is array function. And here we need to provide a list, so opening and closing of round parenthesis. And here let's provide some numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? You can provide any numbers here. It is not necessary that you need to provide it in an order. Right? Like this, you can provide random numbers also. Now here we just want to print even numbers. So in that case, what to do? Usually in case of list, you'll have to write whole program, where you will have to loop through each and every value, and then you will have to check that the specific value is even or odd, and then you will have to print the even values. But here in case of NumPy, it is very simple. What we need to do? We need to provide this array name, which is arr2, and then as we are using Boolean indexing, so opening and closing of square brackets, and here we need to provide the condition. What is our condition? So our condition is that we want to fetch all the even numbers, and for that we can use modulus operator. How to use that? Here we need to provide the array name, which is arr2, and then this modulus operator, and here we will provide 2. So whenever we will divide a number by 2, and if it is giving us 0, so it is an even number, and if it is not giving 0, it is an odd number. So we want to fetch all the even numbers. So here we have provided modulus, which will give us remainder after the division. So 1 divided by 2, we would be getting 1. 2 divided by 2, we would be getting 0. 3 divided by 2, we would be getting 1. 4 divided by 2, we would be getting 0, right? What is this modulus operator, division operator, that I've already explained. If you have not watched videos related to the mathematical operation, you can go and watch that video. I will provide link of that video into the description, or you can click onto this I button at top right corner to access that video. For now, let's complete this condition. So arr2 modulus 2, and it should be equals to 2. So let's provide this double equals to and then 2. What is this modulus operator? What is this double equals to? It is simple Python concept, right? Here we are comparing that value of this arr2 modulus 2 should be double equals to, and here it should be equals to 0. So what is this modulus? What is this double equals to? That we have already discussed. So here we are just providing modulus of this arr2 elements with 2, and it should be equals to 0. So one by one it would be checking for each of the element, it would be comparing, and whatever the elements which satisfy this particular condition, we will see them as the output. Let's save it inside one variable. Here let's give the variable name as even underscore arr equals to. Now let's print value of this particular variable. So print and then this even underscore arr. Now let's click onto this execute cell. And see, we have got one array which is one dimensional array, right? Because this array was one dimensional, and here we are able to see 2, 4, 6, 8 and 10. We have not got any odd number, only the even number got printed because we have provided this condition to check that only even number should be there. So here what happened, right? So here it must have checked that 1 divided by 2 is going to return remainder 1, So this particular condition will be false. 2 divided by 2 is going to provide us remainder as 0. So this particular condition is true. So that's why it has put 2 inside the array, right? So in short, this modulus operator provides us the remainder after the division, and this double equals to we are using for the comparison with this particular number. That's it, right? In case of NumPy array, it is just single one sentence. But in case of list, you'll have to use the for loop. You'll have to check this particular condition, and then only you will be able to identify that which particular number is even or odd. This is just an example, and like this you can do many other things in case of NumPy. Now let's go to the next topic, which is iterating through NumPy array. Iterating means going through each element of an array one by one. We have already seen that how to do this with Python list using for loop. NumPy also allows you to loop through array using simple for loop, and also provide this nditer function for iterating through multi-dimensional array efficiently. Now let's see the practical example. Here let me add this markdown for adding the heading. The heading would be iterate through NumPy array. Let's provide the same heading here. So let's provide double hash space and then this heading. Now let's add one more new code cell, and here let's write our code. So here let's first create one dimensional array and see how we can fetch its values. So here I will give variable name as arr. You can give any variable name. I'm just using again this arr name just to save the time. After that we need to put equals to and then np dot array and then opening and closing of round parenthesis, and here we will provide some numbers inside the list. So let's provide this 10, 20, 30, 40, 50, or a number of items you can put, right? 60. Now let's fetch each and every value of this particular one dimensional array using the for loop. So for that what we need to do, we need to provide this for keyword and then any temporary variable name, then in keyword, and after that we need to provide this array name, and then we need to put colon, and here we will just print each and every value of this particular array. You can do any other operation, but for now I will just print it. Let's hit enter. After one tab indentation we need to provide this print, and then we need to use this temporary variable name. You can give any name for this temporary variable. Let's provide x. Whatever we have given here, we need to use the same name here. Now let's click on to this execute cell and see each and every value of this particular array is getting printed. So this is for the one dimensional array. But what about the two dimensional array? Let's create one two dimensional array. Now let's add one more new code cell. Here let's provide the array name as matrix, as we are using two dimensional array. You can keep any name here. Matrix equals to, and here we need to create a two dimensional array. For that we would be using the same array function. So np dot array and then opening and closing of round parenthesis. Here we need to provide opening and closing of square brackets, and inside it we would be having multiple rows and multiple columns. So to provide multiple rows, again we need to provide opening and closing of square brackets, and then let's put some numbers. So 1, 2, 3. Now we need to add one more row. So after this first row square brackets, we need to put comma, hit enter. Again let's provide opening and closing of square brackets, and let's provide values inside this second row. So 4, 5, 6. Any numbers, any values you can provide here. Now let's first see that how we can fetch each and every row of this particular two dimensional array. Let's hit enter. For that we are going to use for loop only. So for, here I will give temporary variable name as row. So after row we need to provide in keyword and then this array name which is matrix. After that we need to put colon, hit enter. After one tab indentation we will just print value of the row. So print and then row. That's it. Now let's click on to this execute cell and see it is printing each row one by one. So through the first iteration it printed 1, 2, 3 which is the array, and into second iteration it printed 4, 5, 6 which is this second row. But for now we are iterating through the rows, but we want to iterate through each and every element. So for that what we can do? For that we can use for loop. Let's see how to use that first, but after that we would be seeing one simple way. For now let's hit enter. Go to the first column. Here let's provide this for. Again I am using this row as the temporary variable, then in, and then this array name. So it is very similar to this top for loop which we have created. Then colon, hit enter, and now if I will print this row it will give me each and every row, but I want to get each and every element. So to get that what we would be doing, again we would be providing one for loop. So using that we would be iterating through each and every row. And now here we need to provide this for keyword, and then we can provide any temporary variable name. Let's provide var here, in, and now we want to iterate through each and every value of this particular row. So here we would be providing this row, which is kind of one-dimensional array, right? 1, 2, 3, one-dimensional array. 4, 5, 6, again one-dimensional array. Now here let's provide colon, hit enter, and now after 2-tab indentation. 1-tab indentation is for this particular first for loop, and 2nd-tab indentation is for this second for loop, where we are iterating through these rows. Now let's print value of this val. So print opening and closing of round parenthesis, and here let's provide this val. Now let's click onto this execute cell, and see this particular for loop is just printing each and every row, but the second for loop which we have created is printing each and every value of this particular 2-dimensional array. So here what it is doing, it is first iterating through the whole matrix, right, which is our 2-dimensional array, and inside it we are just iterating through each and every row which we are getting from here. So see, here we are passing it like this. We want to iterate through this particular row and want to get each and every value inside this val, and then we are printing it. So for each row which we are going to get from here, this inner for loop is going to get executed, which is going to give us each and every element or value of this 2-dimensional array. Now there is one simpler way, which is by using nditer function. Let's see how to use that. For that I will create one more code cell here. Here I will take example of this same 2-dimensional array. I am creating it again just to make it simple, right? You need not to create the same matrix again into the code. But just to explain it simply to you, I am again creating this 2-dimensional array. Now we are going to use the for loop, but we would be using only one for loop, and we should be able to fetch each and every value of this 2-dimensional array. For that we are going to use this nditer function. Let's use this. Let's hit enter, and here let's provide this for keyword. We are going to get each and every value. So I will give this temporary variable name as val, and then in, and here we need to use this nditer function. How to use that? For that we need to provide this np, which is alias of numpy, and then dot, and then here we need to provide the function name, which is nditer, and then opening and closing of round parenthesis, and here we just directly need to provide value of this 2-dimensional array, which is matrix, or any name you can give. You can give matrix 1 here. You'll have to provide this same name here for this nditer. So we are passing this particular variable name, which is our 2-dimensional array, to this nditer function. And after this nditer function, we need to provide this colon. Hit enter, and after 1-tab indentation, we can just use this print statement, and let's print value of this val. Now let's click on to execute cell, and we should be able to see each and every value of this particular array, which is our 2-dimensional array. Let's click on to execute cell, and see we have got each and every value of this 2D array. But here there is a little change. Previously we were using nested for loop to get the values out, but here we are using nditer function, where we are passing this 2-dimensional array, and which is directly going to give us each and every value of the 2-dimensional array. Now here we are just getting the value one by one, but we can also get the index number. Let's see how to do that. Let's click onto this code, and here let's use this same matrix. I will change name of this matrix 1 to matrix 2, and here we are having multiple values like 1, 2, 3, 4, 5, 6, and this is a 2-dimensional array. Now let's hit enter. Now let's provide this for keyword. After that we want to fetch each and every value as well as the index. So for that we need to provide 2 temporary variables here. First one would be index, and second one would be val1, or any temporary variable name you can give here. After that we need to provide in, and then we would be using one new function, which is ndenumerate. To use that we need to provide this np.ndenumerate. See, automatically this id is suggesting us this ndenumerate. Let's click onto this. Now let's provide opening and closing of round parenthesis, and inside this ndenumerate function we are going to provide one 2-dimensional array, which is this matrix 2. Let's provide this variable name here. Now after this let's put colon, hit enter, and here let's print value of the index and this value, which is val1. So let's provide print, and here I will provide 2 arguments. First would be for the index, so let's print index here. After that we will put comma, provide space, and now let's print value of this val1, which is going to give us each and every element of this 2-dimensional array. Let's provide space after this comma. It is not necessary, but it's better you provide it. And here don't forget to miss this 1-tab indentation, because this is normal for loop, right? What is for loop, how to create it? For that I've already created one video. For that you can click onto this I button at top right corner to access that video. Now let's click onto this execute cell and we should be able to see index number as well as each and every value. So let's say at 0, 0 index, which means 0 row 0 column, we are having this 1. So we should be able to see 0, 0 and then we should be able to see 1, which is this value. Now let's click onto this execute cell and see we are getting this index which is 0, 0 and at that position we were having this 1. At 0, 1 which means 0th row and first column we should be having 2. And like this you can iterate through each and every value of 2D array. Now let's go to the next section, which is array operation and math. NumPy applies math operation to every element of an array automatically without needing a loop. This is called vectorization and is the reason NumPy is so fast. So this is the section where NumPy really blows your mind. With a normal Python list, if you want to add 10 to every element, you need a for loop. But with NumPy, you just write arr plus 10. That's it. NumPy applies it to every element automatically. Let's see the practical example for this. Let me copy this heading. Let's go to VS Code. Here, let's add this markdown and add 4 hashes. Space and save it. Now let's add one code cell. Here, just to explain this concept easily, I will take example of one-dimensional array. But the same thing you can do with any dimensional array. You can use 2-dimensional or 3-dimensional array. Let's give the variable name as arr equals to np.array method we are going to use. Let's provide opening and closing of round parenthesis and then opening and closing of square brackets, and here let's provide some numbers. Let's provide 1, 2, 3, 4, 5, 6, 7, any numbers you can provide. Now let's add 10 to each and every element of this particular array. And I would be using print just to show you the output. So let's use this print function. And after that we need to provide name of the array, which is arr, this one. And then we want to add 10 to each and every element. So for that, what we need to do, we just need to provide plus and then provide the number which you want to add. If you want to add 20, 30, 21, whatever you want to add, just give it here. And automatically it will get added for each and every element. We would be getting a new array with this 10 added to the each element. Let's click onto this execute cell and see it is showing 11, 12, 13, 14 because 10 got added for each element. See, it was too quick. We need not to execute any for loop and then add this number. We just need to add this plus symbol and then this number which we want to add. Similarly, we can do the multiplication. Let's see that. So let's provide print here again. I'm using print, but you can save it inside one variable, right? You can save this arr plus 10 inside one variable and then you can use that particular new array anywhere, wherever you want to use. For now, we are using print just to show you the output at that time only. So print function, opening and closing of round parenthesis. Here we need to provide the array name, which is arr, and then we want to do the multiplication. So let's multiply each and every element of the array with 2. So let's provide this star here for the multiplication, and then we need to provide the number. Let's provide space so that it will look properly. Then 2. It is not mandatory to provide space before and after this symbol, right? Just to make it more visible, properly visible, I am adding spaces. Here also after the comma you can add spaces. Now let's click on to this execute cell and see this second array is appearing where with each element 2 got multiplied. See 2, then we are able to see 4, 6, 8, 10, 12 and 14. Now let's get a new array which will provide power of each element, which means it will multiply each element of the array with itself. Let's say 1 into 1 we would be getting 1, 2 into 2 we would be getting 4, 3 into 3 we will be getting 9 and so on. Let's do that. So for that again let's use this print function only, opening and closing of round parenthesis, and here we need to provide this array name, and to provide the power we need to use this double star. Just to multiply we just need to use this single star, but just to provide the power we will have to provide double star, and power of 2 we are doing, so each number will get multiplied by its own. So 1 into 1, 2 into 2, 3 into 3. Let's click on to this execute cell and see we are getting 1, 4, 3 into 3 is 9, 4 into 4 is 16, 5 into 5 is 25 and so on. Similarly, we can also divide each and every number of this particular array. For that, we need to provide arr divided by 2. Arr is our array name. Let's use this print function again. Print and then arr divided by 2. You can provide any number. Let's say if you want to divide it by 3, 4, 5, so that you can give any number. Now let's click on to this execute cell and see each and every number of this particular array is getting divided by 2. 0.5, 2 by 2 is 1, 3 by 2 is 1.5, and so on. Now let's get modulus of this particular array. Previously also we have seen this example just to print the even number. How to do that? So we need to provide this print, and then here we need to provide the array name, and now we need to use this modulus operator, which is this percentage symbol. And then we need to provide the number. So modulus is something which we get after the division. Let's say we divide 2 divided by 2. So after that we will be getting remainder, and that remainder is this modulus which is going to provide us. So let's divide it by 2. You can provide any number here. So 1 divided by 2, the remainder would be 1, so we should be able to see 1. 2 divided by 2, then the remainder would be 0, so we should be able to see 0. Now let's click on to this execute cell. And see, we are only seeing 1 0 1 0, because if we are dividing any number by 2, we are going to get either 0 as the remainder or 1 is the remainder. You can provide any number here. On the basis of that, you will be getting remainder here. And here only we can also see operation between two arrays. For that, let me add one more code cell. Let's provide the heading as operation between two arrays. Now let's hit enter, and here let's create two array. So a equals to np.array, opening and closing of round parenthesis, opening and closing of square brackets, and here let's provide some number like 1, 2, 3. Now let's create one more array. Let's give the variable name as b equals to np.array, and here let's provide some numbers inside the list like 10, 20, 30. You can provide any numbers here. Just to explain it to you, I am just creating these three numbers. You can provide any numbers and any number of times. Now what we want to do? We want to, let's say, add these two arrays. So how we will be able to do that? So in that case, we will have to just provide a plus b. That's it. It will add 10 with the 1, 20 with the 2, 30 with the 3, and like this. You can do any other operation also like multiplication, division. Let's see that quickly. So let's provide this print here, and then a plus b. Now let's click on to this execute cell, and see we have got 10 plus 1 as 11, 20 plus 2 which is 22, 30 plus 3 which is 33. And here remember one thing, that your array should be of same size. Let's say this first array is having 3 elements, but this second array is having 4 elements. Let's provide that quickly. Let's provide some number here, 33, or any number you can provide. Now let's click on to execute cell, and see we have got that operation could not be broadcast together with shapes 3 and 4, because for this first array it was having 3 elements, and for the second array it is having 4 elements. So remember, for both the arrays number of elements should be same. Now I've removed that. Let me again execute it, and we have got the output. And similarly we can do any other operation. Let's do the multiplication. So let's provide print here, and then a into b, which means a star b. Let's click on to this execute cell, and see we have got 10 into 1 which is 10, 20 into 2 40, 30 into 3 90. Similarly we can do the division also. Let's do that, and then b divided by a. You can also do a divided by b, but this b is having larger number, so I am dividing b by a, so that we would be able to see clear output. You can do anything like this. You can do a divided by b, or you can create a new array with higher numbers, so that it would be easy for you to see the output, that what kind of division it has done. Now let's click on to this execute cell, and see 10 divided by 1 is 10, 20 divided by 2 is 10, 30 divided by 3 is 10. It is showing 10, so don't get confused, right? It is just dividing elements of b with elements of a. So it would be performing operation between same index values. So here it added 10 with 1 because for both of them index is 0. Here for both of them, which is 20 and 2, the index is 1. And like this it is going to do the operation between numbers which are at the same index. Now let's see the next concept, which is broadcasting. Broadcasting is NumPy's ability to perform operation between arrays of different shape by automatically stretching the smaller array to match the larger one. So this broadcasting is very powerful. So understand it like this, that we are having two arrays of different shape. NumPy is smart enough to figure out how to apply the operation anyways, by stretching the smaller array to match the bigger one. Let's see the practical example quickly. Let's create two arrays. Let me copy this broadcasting heading also. I will provide it as the comment. Now here let's add this code cell. Let's provide it as the comment, so hash and then this broadcasting. Now hit enter. Now let's create a one-dimensional array and the two-dimensional array. Let's give the one-dimensional array name as matrix equals to np.array, and here let's provide two-dimensional array with the numbers like 1, 2, 3, 4, 5, 6. How to create it? That we need not to repeat it again. Opening and closing of square brackets. Again, in the first row I will provide 1, 2, 3, and then into the second row I will provide 4, 5, 6. 4, 5, 6. This is our two-dimensional array. Hit enter. Let's provide one-dimensional array. Here I will give the variable name as row. Then equals to, and then np.array, opening and closing of round parenthesis, opening and closing of square brackets, and here let's provide 10, 20, 30. Now let's add this two-dimensional array with one-dimensional array, and let's see what is the output. Here I will print it. So print then matrix, which is our two-dimensional array, plus one-dimensional array, which is row. Here the spelling is matrix, M-A-T-R-I-X. Now let's click on to this execute cell and see it has added this 10, 23 to each and every row of this two-dimensional array. So it added 10 with this 1 as well as with this 4. It added 20 for the second column for each row. So 20 with the 2, which is 22, 20 with the 5, which is 25. Similarly for the 30, we have got 33 and 36. 30 plus 3 and 30 plus 6. So usually in case of AI, broadcasting is used when normalizing image pixel values. You subtract the mean from the entire dataset in one operation. No loops needed. For now, you need not to be worried about these AI terms, right? When we would be learning AI, we would be using these concepts. So if you are not getting what is image pixel value, what is mean, so you need not to worry about for now. You just need to know that what is broadcasting and how the operation will get performed onto arrays of different shape. Now let's talk about the next concept, which is math function or universal function. Let me provide math also here so that you do not get confused. You can call it math or the universal function. So NumPy universal functions, you can also call it U functions like square root, log, exponential, apply mathematical function to every element of an array at once. It is much faster than using Python loop. Let's see how to use that. Let me copy this heading. Let's go to VS Code here. Let's add one more new code cell. Let's provide heading here, so hash, and then this particular comment. Here, heading when I'm saying, so I'm just putting a comment. At some places, I'm also dividing it into the section because still we are under this array operation and math section. But inside it, there are multiple subsections. Now let's hit enter. And here, let's create one array. I will take example of one-dimensional array. You can also try it with the two-dimensional array. Now here let's provide the array name as arr equals to np.array, and then opening and closing of round parenthesis, then opening and closing of square brackets, and let's provide some numbers here. Let's provide 1, 4, 9, 16, 25. You can provide any numbers, right? I'm just providing these numbers so that it would be easy for you to calculate output of these mathematical functions. Now let's use these math function or universal functions or U functions. You can call it anything. Hit enter. Let's use the print statement only just to show the output. And here first we are going to use square root. For that we need to provide this np.sqrt and then opening and closing of round parenthesis, and then we need to provide this arr, which is our one-dimensional array or any type of array you can provide here. Now we are going to get square root of each and every element of this array. So square root of 1 would be 1. For 9 it would be 3. For 16 it would be 4, and so on. Now let's click on to this execute cell and see we have got 1, 2, 3, 4, 5 because we are getting square root of these numbers. That's why I have taken numbers like this so that you are able to see output of these operations easily. Similarly, we can use other math operation also. We just need to provide np and then that function name, which is our U function or universal function, and then we need to pass the array. That's it. Let me use this log function. So print np.log, and here opening and closing of round parenthesis, and let's provide this array name, which is arr. Now if you will click onto this execute cell, it is providing natural log of each and every value of this particular array. How to calculate this log? You can just Google it, right? I don't want to take much time to explain math to you, right? We would be learning about math later, but here this is NumPy tutorial, so I don't want to go away from this particular topic. Now similarly, we can also get the exponential value, which is e raised to each power. Let's see that. For that, let's use this print statement, and then we need to provide this np.exp. Then here we need to pass argument, which is array, which is ARR, right? This array name. Now let's click onto this execute cell and see we are getting e to the power 1, e to the power 4, e to the power 9, and like this you can provide any numbers here and you will be getting this exponential value for that, or the exp value for that. Now there is one more function which is abs, which will give us the absolute value. Let's use that. So here let's use the print statement, and here I will pass one array with a negative value. If you want, you can create one array. I will directly pass array here. I don't want to reuse this array, so that's why I'm providing it directly here. So here inside this print function we need to provide np.abs, which is absolute function, and then inside it we need to pass one argument. The argument would be the array itself. So for that we can provide this np dot, and here we need to provide the array, so array, which is our function, and let's pass one list with the negative values also. So let's give values as -3, -2, let's provide some positive values also like 0, 1, 7, -9. Now let's click on to execute cell and see we have got one new array where we are not getting any negative value. Automatically it got converted into the positive value. So for -3 we are getting 3, for -9 we are getting 9, and each negative value will get converted. For 0 it is a positive number, we have got 0 only. For 1, 7 those are positive only, so there is no change. Now let's get sign of each number. For that we can provide this print, then we need to provide this np dot and then sin, and here we need to pass the array. I'm not wasting my time to explain that what mathematical operation it is doing. You just search for this square root, log, exp, absolute values, how to calculate the sign, and you will be able to get it, right? But how to use this function, that you should be aware about it, right? We just need to provide np dot function name, and then we need to pass the array for which we want to do this mathematical operations. Now let's click on to this execute cell and see it is providing sign of each number inside this particular array. Now let's see one more concept, which is dot product. For that we will require two array. Let's do that inside one new code cell. Here we are going to see dot product. Now let's create two arrays. So a equals to np dot array, and here let's provide 1, 2, 3 inside a list. Similarly, let's create one more array with the name b. Let me copy it. Let's change this variable name to b, and let's change these numbers to 4, 5, 6. So 4, 5, 6. Now let's use this dot function. How to use that? So for that you just need to provide this np dot, and then we need to provide the function name, which is dot, and here we need to pass the two argument, which would be first array and the second array, so a b. Now let's put it inside one print function so that we are able to see proper output. So print, and here let's put this np dot dot, and now let's click on to this execute cell and see what is happening. We have got one error because I've provided this function name wrong. Let me correct it. It should be array. I've provided this r 3 times. Now let's again click onto this execute cell and see we have got 32. How we got it? So here it multiplied values of these two arrays at the same index position, and then it added it. So here it multiplied 4 with the 1, which is 4, then 2 with the 5, which is 10, and then 6 with the 3, which is 18, and then it added all these multiplication. So 4 plus 10 plus 18. So 4 plus 10 plus 18 is 32, and that's what we have got here. Now let's see the next concept, which is matrix multiplication. Matrix multiplication combines two 2D arrays following a specific math rule. It is a core operation behind every neural network, and it is done using this particular function, which is MAT-MUL. MAT is for matrix and MUL is for multiplication. Now let's create two 2D arrays. Let me copy this heading. Let's go to VS Code. Here let me click onto this code Let's provide it as the command. Hit enter, and here let's create two array. So x is the array name I am giving, equals to, and then np.array, and here we are going to create one 2D array. So opening and closing of round parenthesis, and here opening and closing of square brackets, and then we are going to add two rows. So let's provide this first row. Here let's give two values only, 1, 2. I'm trying to make it simple, so that's why I'm taking two values only inside the row. You can try increasing the value and try to get the output. Now let's add the second row. So opening and closing of square brackets, let's provide 3, 4 here. So 3, 4. Now similarly we can create one more array. Let me copy it and we will change the values. Let's change this variable name to y, and here we will provide 5, 6 for the first row and 7, 8 for the second row. You can provide any number, but just to explain you it into the simple way, I am taking these simple numbers. Now we have two 2D arrays. First one is this one and second array is this one, and both are 2D arrays, remember. Now we want to do this matrix multiplication. There is a proper formula for this matrix multiplication. For now, first let's see the output. So for that, what we need to do, let's use this print statement only, and then opening and closing of round parenthesis, and here we just need to simply use this np dot mat, which is for the matrix, and then mul for the multiplication. So using the short form, this particular name got created, and it is predefined function by NumPy, right? We are not creating it. Now here for this mat mul function, we need to provide two arguments, which will be these two 2D arrays. So x is the first 2D array, then comma we need to put, and then second 2D array, which is y. Now let's click onto this execute cell and see what we are getting. See, after this matrix multiplication, we have got one 2D array with two rows where we are having this 19, 22, 43 and 50. So how we got this? So what is this matrix multiplication? So during your math study, during college or during schools, you must have seen this matrix multiplication. So how it happens, let me quickly show it to you. So here we have got two rows with the two columns, and here we multiplied two arrays which were 2D array. There also we were having two rows and two columns. Now let's see how this matrix multiplication is happening. I don't want to go in much detail, but I want to just quickly explain you this particular example, that how we are reaching to this particular output. So here see what is happening. Let me add it here. I will comment it out for you. So now let me create one 2D array. So this opening and closing of square bracket, and then again for the first row we will put this opening and closing of square bracket. I'm just putting it just to show you that what is internally happening, how we are getting all these four values. So first we have got 19. So how this matrix multiplication happens, this first row of this first array is getting multiplied with first column of this second array. So what is happening? So here this 1 is getting multiplied by 5. So 1 into 5. Then this 2 is getting multiplied by this 7. So here I will put this plus and then 2 into 7. Right? So this row got multiplied with this particular column. Now we have got our first element of this 2D array. So see, 1 multiplied by 5 is 5. 2 into 7 is 14. And 5 plus 14 is 19. We have got 19. Now similarly, how we are getting the second element? So in that case, this first row is getting multiplied with this second column. So now what is going to happen? Let me put some more spaces. And here, this 1 is getting multiplied by 6. So 1 into 6 plus 2 into 8. And we will get our second element for this first row. So 6 plus 8 into 2 is 16. So 16 plus 6 is 22. Similarly, for the second row, how we are getting the items? Let's see that. Let's hit enter. Let's provide this opening and closing of square brackets just to make it simple. Now here what is going to happen? This second row is going to multiply it with this first column. So 3 into 5 plus 4 into 7. Let's do that. 3 into 5 plus 4 into 7. Right? 3 with 5, 4 with 7. Right? Second row with first column. And now let's calculate it. So 5 into 3 is 15. And 7 into 4 is 28. So 28 plus 15 is 43. Now similarly, we are going to get this 50. And how it is happening? So this second row is getting multiplied with this second column. So 3 into 6 and 4 into 8. Let's put it here. So 3 into 6 and 4 into 8. So see, 6 into 3 is 18 and 4 into 8 is 32. So 32 plus 18 is 50. And like this matrix multiplication is happening. If you are not aware about the matrix multiplication, you just search into the Google, you will get the formula and then you can put that formula here. But here in case of NumPy, we just need not to do any of this calculation, right? We need not to iterate it through the for loop and then do this multiplication and addition. We just need to use this mul function, which is for the matrix multiplication. That's it. Let me comment out these two rows, right? Like this, you can try to provide any other number and you can increase number of rows and number of columns and see the output. In actual scenarios, you will not be having such a small data, but just to explain it to you, I have taken this small set of data. So matrix multiplication is core operation of every neural network. Every forward pass, every backward propagation, it is all matrix multiplication under the hood. You just learned the math behind AI. If you are not getting any of the words like neural network, forward pass, backward propagation, you need not to be worried about that right now. When we will learn those topics, we will be seeing that. Just for your information, I wanted to add it here. Now let's go to the next section, which is reshape and transpose. So reshape changes the shape of an array without changing its data. And transpose flips the rows and columns. Both are used constantly in AI to prepare data for models. For now, you need not to be worried about AI part or that particular sentence, right? But just for your information, I wanted to provide these information also here, so that later when you are learning the AI, you would be able to connect the dots. When we are learning AI at later part of this series, you can again rewatch this particular video or rewatch this section so that your concept would be more clear. For now, let's proceed further with a practical example. Before that, let me copy this heading and now let me create one new section. So for that, I will provide this markdown and here let's provide 4 hash space and then this heading. That's it. Now let's add this code cell. Now here first we are going to use two functions which are reshape and transpose. Now here let's first see how to use this reshape function. Now let's create one array. So to create one array, I will give the variable name as arr equals to, and this time to create an array, rather than using this array function, we would be using arange. What is arange? We have already talked previously. You can go back and watch that particular part again about the arange. So with this arange, we can provide starting and ending point and we would be getting one-dimensional array. Let's do that. Now opening and closing of round parenthesis, and here we need to provide the start and stop point. Let's provide start point as 1 and end point as 13. So now what will happen? It is going to give us one-dimensional array where it would be having values from 1 to 12. This stop point will not get included. Now let me print value of this particular array. So print and then arr. Let's click onto this execute cell and see we have got one array where it is having values from 1 to 12. Here with this arange you can also provide the step. So it will step with those numbers that I've already explained, but for now we just wanted to create an array with these numbers. That's it. So every time whenever you provide any number, let's say you provide 1, 21, so it will create an array with the numbers from 1 to 20. But here we want to learn about reshape. So how to do that? So now we have created one-dimensional array. Let's check its shape also. So for that again let's use this print and then arr.shape. Let's again click onto this execute cell and see its shape is 12, which means it is having 12 elements and it is one-dimensional array, right? It is showing 12 elements. Now let's use the reshape. So let's say we want to convert this one-dimensional array into two-dimensional array where we are having 3 rows and 4 columns. Means each row will be having 4 items. So first row 4 items, second row 4 items and third row 4 items. In total it would be having 12 items only, right? So how to do that? So in that case only we are going to use this reshape function. Let's use that. Let's hit enter here. And here we will provide one variable name as reshaped array. Reshaped underscore array. You can provide any variable name. Then equals to. And here we need to provide the array name which is arr, right? Whatever the name which you provide here, you need to provide it here. Now we need to provide dot. And then we are going to use this reshape function. So after this reshape, we need to provide opening and closing of round parenthesis, and then we need to provide number of rows and columns that what new shape we want for the old array. So for this one dimensional array, we want 3 rows. So we will provide 3 here as the first argument, then comma, and then 4 columns we want. So we will pass this 4 as the second argument. Right? We are just directly providing the arguments. We are not providing any tuple. So just make sure that wherever I have told that we need to pass the tuple, you pass a tuple. Wherever I have told that you need to pass a list, you need to pass a list. Here we are just passing the argument, not tuple, not list. Now let's print value of this reshaped array. So print and then this reshaped array. Now let's click onto this execute cell and see it is printing this 2D array where we are having 3 rows and each row is having 4 columns. So we have got this 1, 2, 3, 4 inside the first row, 5, 6, 7, 8 inside the second row, and then 9, 10, 11, 12 inside the third row. And here you need to make sure that it is satisfying this particular array condition. So it should be having 12 elements, right? Row into column, which is 12. So that's why this 12 element 1D array is getting converted into 2D array. And it is not necessary that you need to provide 3 and 4 here. You can also provide 2, 6, where it would be having 2 rows but 6 columns. Let me execute it. See, it is having 2 rows but 6 columns, which means inside each row we are having 6 elements. We can also do 1, 12. Let's execute it. So here we have got only 1 row, but it is having 12 items. We can also do 12, 1, which means 12 rows and 1 column. So now we are going to get 2D array and each row would be having 1 element only. See, like this. We can do 6, 2. So it's up to you what you want to provide here. But make sure that whenever we are reshaping an array, we satisfy this condition. So that here if you will see 6 into 2, we are going to get 12 elements. 1 into 12, we are going to get 12 elements. You cannot do 5 into 3 because in that case it will require 15 elements. But whatever the previous array which we are reshaping was only having 12 elements. Let's execute it and see we have got 6 rows and 2 columns. For now, let's switch back to the 3, 4. And here one more concept which you should be aware about. Let me show that to you, then I will explain it. So here I will provide array name as reshaped array or array1 equals to, and here we will use this old array which is arr dot reshape and then opening and closing of round parenthesis, and here we can provide row number. Let's provide row number as 3, comma, and now rather than calculating it, we can just simply provide -1. So automatically this reshape function will calculate that how many columns it should get, which means inside each row how many elements should be there. Now let's print value of this array1. Now let's click onto this execute cell and see we have got this particular output where it is having 3 rows and here we have not provided column numbers and it got automatically calculated because of this -1. Let's say if I provide 6 here, so in this case there should be 2 columns, but we are just providing -1. Let's execute it. See, we have got 6 rows and 2 columns automatically. And for the rows also we can provide -1. Let's say I provide -1 here, but for the column in that case we will have to provide one fixed number. Let's provide 4 here, or let's provide 3 here. So automatically it should create 4 rows and 3 columns because we are providing -1. So this calculation will be happening automatically. Let's click onto this execute cell and see it created a 2D array with the 4 rows because we have provided -1, so automatically it calculated it. And this 3 as the column we have provided, so it is having 3 columns, which means each row is containing 3 elements. If you will not provide these numbers properly, let's say you do 3, 5, so in that case you will be getting error. That you can try as the assignment. I'm not showing you error, but you can try to fail it and see the output. And in case of any issue, any doubt, just feel free to reach out to me into the comment section below. Here like this, we can also check shape of the array. Let's check it. So print and then array1.shape. So we want to check shape of this new array. array1.shape. This shape is the property. Now let's click onto this execute cell and see we have got this 4, 3. 4 is number of rows and 3 is number of columns. For this it was 3, 4. Let's try to print that also. So print and then reshaped array dot shape. And here we should get 3, 4. See, we have got 3, 4. Right here we are printing the array and then we are printing shape of the array. 3, 4 means 3 rows, 4 columns, and automatically it is having rows and columns, so it is a 2D array. So think of reshape like taking 12 tiles and arranging them differently. 1, 12, 2, 6, 3, 4, same 12 tiles, different arrangement. Data does not change, only shape does. Now we have learned about reshape. Now let's see the use of transpose. So for that I need to create one 2D array. I will copy this 2D array only. And now let's add one more code cell. Here we are going to learn about transpose. So let's provide this transpose here. And here we can provide reshape. Let's give the variable name as matrix equals to, and then we need to provide np dot array and then opening and closing of round parenthesis. And here let's create a 2D array. So let's provide opening and closing of square brackets. And here let's put 2 rows. So first row we are having this 1, 2, 3. Then comma after this first row, and into the second row we are going to have 4, 5, 6. Like this you can put n data, n number of rows, n number of columns. So now as we are talking about transpose, so what it does, it flips rows and columns. See this one. Let's see how to do that. But before that, let me print shape of this particular 2D array. So print and then matrix dot shape. Now let's click onto this execute cell and see it is showing 2 rows and 3 columns. Now we are going to transpose it. Let's do that. For that we need to provide the print statement so that we can see the output, and then we need to provide this array name which is matrix dot, and then we need to provide capital T here. That's it. And then it is going to give us transposed array. Now let's click onto this execute cell and see our rows got converted into column. This 1, 2 and 3 are appearing as the column. Previously it was row. This 4, 5 and 6 are appearing as columns. Previously it was row. We can also check shape of this new transposed array. You can either save it inside one variable and then use this dot shape there, or we can also do the chaining. Here we can provide print then matrix dot t, which is going to give us transposed array, and then we can do this dot and then shape. And now let's click onto this execute cell and see this time the shape is appearing as 3, 2 because it is having 3 rows and 2 columns. Previously it was having 2 rows and 3 columns. So now our rows got transposed to column. 1, 2, 3 is column, 4, 5, 6 is a column. That's it. You can try to provide multiple rows, multiple columns and try to transpose it. If you want, you can also check the shape every time. So transposed is used in every neural network layer when you multiply input data with model weights. One of them needs to be transposed. This is why T is everywhere in the AI code. For now, you need not to be worried about it. If you are going to use this particular concept later, at that time you should be able to recollect it. That's it. If we do not use it, that is okay. But if we are using it at any place, you should be aware about this particular concept. At the time when we are learning that, you can come back to this particular concept for this video and see it again if you're forgetting it. And with this reshape and transpose, we should learn one more concept, which is flatten and ravel. Both convert a multi-dimensional array into 1D array. Flatten returns a copy, while ravel returns a faster view of original data. Let's see the practical example. Let me copy this heading also. Let's go to VS Code. Here we will add new code cell and let's provide it as the command. Now hit enter. Let's create one 2D array. Let's copy this same array only. Here you can also try to provide 3-dimensional array, but with 3-dimensional array it would be little complex for you to understand these simple concepts. So that's why either I am using 1D array or 2D array. Now to use it, you just need to simply provide the array name dot flatten or ravel method. Let's use that. For that I will provide the print statement or print function, and here we need to provide this array name which is matrix dot, and then we need to provide this function which is flatten, FLATTEN, and then opening and closing of round parenthesis. Now let's click on to execute cell and see we have got one-dimensional array. So it has converted this 2-dimensional array into 1-dimensional array, and here it is creating one new copy. We can similarly use this ravel, which will not create a copy, it will just show you the view. Let's do that. Let's use this print statement. Again, we need to provide this array name, which is matrix dot, and then here we are going to provide the function name as ravel. So ravel. Then opening and closing of round parenthesis. Now let's click on to this execute cell. See, in both the cases, we are converting this 2D array into 1D array. In case of this flatten, we are creating a copy. In case of ravel, we are not creating a copy. We are just showing the view. Now let's go to the next section, which is statistical functions. NumPy provides functions like mean, median, std for standard deviation, min, max to quickly analyze and understand data before training any AI model. Now let's see the practical example. Let me copy this. Let's go to VS Code. And here let's create one new section. Click on this markdown. Provide for hash space heading and then stop editing. Now let's add one more code cell. And here we will take example of 1D array. So let's give the array name as scores. Here we are taking example of students scores. So that's why I have given this name as scores. Now equals to then np.array, then opening and closing of round parenthesis, and here let's provide student marks one by one. So here let's provide 85, 92, 78, 95, 88, 72, 91, and like this you can provide number of scores here or number of elements. Now let's use each and every statistical function one by one onto this particular array, which is our score data, right? You can take any example like temperature data or any other math score data, right? Now first statistical function which we are going to use is sum, which is going to provide sum of all these elements. How to use it? Let's see that. Let's provide print function so that we are able to see the output, and inside it we would be providing our expression. And let's put some comments also. So with the print statement we would be able to see some text. Here let's give the comment as sum. So sum and then colon, and again let's put space. So here we are just adding this text just to show that to you into the output, so that if we will use multiple functions we would be able to easily identify. Now let's put comma here, and now we want to use this sum function. So for that we would be using this np, which is alias of our numpy dot sum, and inside it we need to pass the array. So opening and closing of round parenthesis, and here we need to pass this array which is scores, right? Now let's click on to this execute cell and see we have got 601, which is addition of all these scores or all these values, right? It is very simple. We just need to provide np, then the function name, and as an argument we need to pass the array. Now let's use this mean function. For that again I will provide print. Here I will add one text as mean colon space. Then let's provide second argument, and here we need to provide np dot mean, and then opening and closing of round parenthesis, where we would be passing this array which is scores. You can pass any array. For that you want to calculate this mean value. So this mean is calculating average. Read the description. It is showing returns the average of array elements. So what would be the average? So there it would be adding each and every value divided by number of elements. So here we are having 1, 2, 3, 4, 5, 6, 7 elements, which means 601 is the sum divided by 7, and we should be able to see the mean value. Let's click on to this execute cell and see 601 by 7 equals to 85.85. This float value is appearing. Provide numbers n number of times and then try to calculate sum, mean. Similarly, we can also calculate median, standard deviation. Let's see that. You can directly Google formulas for mean, median, standard deviation. For now, I'm not going in much detail about this math calculation. When we would be learning math into the different section of this particular course, at the time I would be explaining each and every math concept which is required for AI engineering separately with more details to you. For now, you just need to be aware that there are such functions and you can directly use them into the NumPy. Now let's try to use this median. For that again let's provide this print, and then let's provide one comment as median. Then space colon space. I'm providing this space colon space just to show output properly. Now we need to provide the second argument for this print function. It is not necessary that you always use this print function. You can save this particular value which is output of this sum, mean, median into one variable and can use it into your code anywhere. Now here let's provide np dot median is the function name which we need to use, and then opening and closing of round parenthesis, and here we need to provide array name which is scores. Let's click onto the execute cell and see we have got median as 88. How to calculate this median? For that you can just Google it. You can also use ChatGPT Claude and you would be able to understand it. For now, as I told, I am not going into much detail, that we would be seeing later. So don't worry if after Googling it or after searching it onto the AI assistant you are not getting this median standard deviation concept. It is little tricky to understand. I would be covering each and every part with the math. Now let's see how to get output of the standard deviation. For that again I will use this print function, and here let's provide this comment std dev colon space, and then let's provide the second argument which is np dot std is the function name for calculating standard deviation. Here you can read more details about this std function, and here we need to provide opening and closing of round parenthesis and this array name which is scores. Now again let's click onto this execute cell and see we have got the standard deviation number. Similarly, we are also having min max function. Min will be providing minimum value of this particular array and max will be providing maximum value of this array. Let's see that quickly. So print, and then min is the comment which I am giving, and then here we are going to use this np dot min is the function name, and then opening and closing of round parenthesis, and then the array name for which we want to calculate the minimum value. For now we are having just 6, 7 values or 8 values, but in case of actual data you will be having hundreds and thousands of elements or thousands of items inside the array. So in that case it is very helpful to calculate that which one is the minimum value, which one is the maximum value, right? With the AI engineering we are going to use such concepts. That's why I am covering it here. Now let's click onto this execute cell and see the minimum value we are getting as 72, which is this one, right? This is the lowest or the smallest value. Similarly, we can also get the maximum value. For that again let's use this print statement. Here let's put some text max colon space, and then to calculate max we need to use this np dot max is a function name, opening and closing of round parenthesis, and there we need to pass this array which is scores. Again let's click onto this execute cell and we have got this 95 as the max one, because 95 is the largest number which is available inside this array. For now we have just seen the example of one-dimensional array, but what if we are having two-dimensional array? So how this calculation will be happening? Let's see that quickly. For that I will add one more new code cell, and here I will create one 2D array. I will give the name of this array as data equals to, and then np dot array, then round parenthesis, and then opening and closing of square brackets. Here let's provide first row, so opening and closing of square brackets again, and then I will provide the values as 10, 20, 30. Similarly, I will provide the second row. So after this first row, put comma, then square brackets, then 40, 50, 60. Again, comma after the second row, hit enter, square brackets, and then 70, 80, 30. Then put any numbers. I'm just putting simple number here. If you want, you can add spaces also just to see it properly, like this. Now here we can output either for each row or for each column. We can get any of the output. Like we want to get the sum, so in that case what we will have to do? We will have to provide np dot sum, and then opening and closing of round parenthesis. There we need to pass the array name, which is data in this case, which is our 2D array. After that we need to put comma, and then if we want to calculate stats based on columns, so in that case what we will have to do? We will have to provide this axis equals to, and in case of column calculation we need to provide axis as 0, and in case of row calculation we will have to provide axis as 1. For now let me print the output. For that I will print this particular expression. So print opening and closing of round parenthesis, and then let's put this expression here. Now let's click onto this execute cell, and we have got one row where we are able to see 120, 150 and 180. So what is that? So we are getting sum of each column. So if we will add this 70 plus 40 plus 10, which is 120. Here 80 plus 50 plus 20 is 150. And then 90 plus 60 and 30 is 180. So like this you can try to provide axis as 0. If you will provide axis 1, so it will provide sum for each row elements. Let's click on to this execute cell and see we have got 60 here because 10 plus 20 plus 30 is 60. Then we have got 150 for some of these elements. And then it is 240 for some of these elements. So like this, if you are having any 2D array, so you can provide this axis. To calculate it based on the columns, you can provide axis as 0. So if you want to calculate all these stats like sum, mean, median, standard deviation, min, max based on the column, so in that case you can provide axis as 0. But if you want to calculate it based on the rows, so you can provide axis as 1. And this axis is the second argument which we are passing with all these functions. Similarly, let's try to use it onto the mean. For that, let me use this print statement only. Then here we will provide np.mean and then opening and closing of round parenthesis, where we know we need to provide this array name. So in this case, our 2D array name is data. After that, we need to pass second argument for this mean function. So comma space, and here let's provide axis equals to 0, which means we want to do the calculation based on the column. Now let's click on to this execute cell and see we have got 40, 50, 60. Why so? Because it is calculating mean, which means it is calculating average based on these columns. So 10 plus 40 plus 70, which is 120, then divided by 3 because these are 3 elements. So we have got 40. Similarly, here we are having 80 plus 50 plus 20, which is 150, divided by 3 equals to 50. Like this, it will be calculating data based on the columns. Similarly, if you want to change and want to calculate based on the rows, so in that case you can provide the same statement, but here you will have to change this axis equals to 1. Let's again click onto this execute cell and see this time it is providing 20, 50, 80 because here it is doing the calculation, this average calculation for these rows. So 10 plus 20 plus 30, which is 60, divided by 3 equals to 20. 40 plus 50 plus 60, which is 150, divided by 3 equals to 50. Similarly, 70 plus 80 plus 90 divided by 3 equals to 80. And like this, you can do any calculation for any dimension of array. Similarly, you can try to apply other functions also like median, standard deviation, min, max for the rows or for the columns. And here, one more thing you can do, that you can calculate output of the sum, mean, median, standard deviation, min, max for all the values of this 2D array also. In that case, you will not have to make any change. It would be very similar. You will have to provide np and then the function name and then just provide the array name. After that, we need not to provide this second argument of axis. Let's just quickly see that. So let's try the sum first. So print np dot sum, and here within opening and closing of round parenthesis, we need to pass this array name, which is data, which is our 2D array. Now let's click on to this execute cell and see we have got sum as 450. Similarly, we can try mean also. So let's copy the same sentence. Here I would be using mean. Let's click on to this execute cell and see we have got mean as 50. So addition of all these numbers divided by 9, which is 50. And like this, you can also try to calculate median, standard deviation, min, max. Let me just quickly show one example for max also on min. For now, let's cover max. It is very similar, so that's why I'm not repeating it again. And here we need to provide np, max, and then array like we provided for the one-dimensional array. Now let's click on to this execute cell and see we have got 90, which is our maximum number or the largest number. Like this, you can also try to calculate min, standard deviation, median, right? So it's up to you. For in case of 1D array, you just need to provide the array. In case of 2D array, if you want to do the calculation based on the column or the rows, so you can provide axis. If you want to consider all data and then you want to get this output, then you'll have to just pass the array name with these functions. Now let's see one more concept, which is argmin and argmax. So this argmax returns the index of the highest value and this argmin returns the index of lowest value. These are used in AI classification models to find the predicted class. For now, if you are not getting this particular line, that is okay. You should be able to get that how to get index of the highest value or the lowest value using this argmax and argmin. Let's see that. Let's go to VS Code. Here, let's add one more code cell. Let me add this argmax and argmax as the command into the cell. So hash and this command, hit enter. Now let's create one dimensional array of the scores only. So scores equals to and then np.array, opening and closing of round parenthesis, then opening and closing of square brackets, and let's provide numbers of different students. So for student 1, he has got 85 score. For student 2, it is 92. Similarly, we have 78, 95, and then 88. You can put any data here. Now let's see use of this argmax. So whenever we are going to use this argmax, so in that case we are going to get index of the largest number. So here the largest number is 95, and for this 95, what is the index? So index is 0, 1, 2 and 3. So we should be able to see output as 3. Let's see that. So for that, what you need to do, you need to use this np then argmax, and there you need to pass the array. Just to print the value, I am using this print statement or print function. Then print opening and closing of round parenthesis, and here we need to pass this np argmax, opening and closing of round parenthesis, and here we can pass the array name, which is this course. Let's copy it, let's paste it here, and now we should be able to see index as 3. Let's click onto this execute cell and see we have got the output as 3. Similarly, we can do the same thing for the argmin or argmin. Again, let's provide this print, and inside it we are going to provide this np.argmin, and then opening and closing of round parenthesis, and here we are going to pass this scores, and we should be able to see index of the smallest number. So the smallest number here is 78, and its index is 2, right? 0, 1 and 2. So we should be able to see the second output as 2. Let's click onto this execute cell and see we have got 2 for this particular print statement. For this argmax, we have got 3 because 95 is the largest number, and we have got the index for that, where it can be helpful. So let's consider one example. You are having one list of the students for which you have created this array where you have the score for each and every student. So here let's create list of students. So for that we need to provide one variable name, which is students equals to, and here let's just create a simple list. So opening and closing of square brackets, and here let's provide some students name like Ram, comma Shyam, comma WishInfinite, comma Sam, comma Alon. I'm providing students name, so that's why I'm using single quotes or double quotes here. Here for now I'm using single quotes just to provide the string. Now we have the list where we are having 5 students, and here we have created the array where we are providing scores or marks of these students. So for the Ram, the score is 85. You can consider any subject like math or bio, right? So for the Ram, score is 85. For the Shyam, score is 92. For WishInfinite, score is 78. For Sam, it is 95. For Alon, it is 88. Now from this list we want to calculate that who is the student who got the highest mark or who is the student who got the lowest mark. So how to do that? So in that case we will have to provide the index number to this students list. So students, and then opening and closing of square brackets, and then we can provide this np.argmax, and then this is score, which is going to give us the index number like this 32. So let's say if it is argmax, so we are going to get the index number for the largest value, which is 3, and then we would be able to get the student who has scored highest. So in this case it would be Sam. Let's see that quickly. So here let's use this print function, opening and closing of round parenthesis, and here we are going to use this students list name, and after that we are going to provide the index number. So here let's say if I provide index number as 3, which is for the same, so we will be getting Sam as the output. Let's see that quickly. But now we want to get the name of the student who has scored maximum. So in that case what we can do, we can simply put this particular expression, which is np.argmax, and there we are passing this score as the argument, which is going to return us the index number, and by using this index number here we are going to see the output for the student who has scored maximum. Let's do that. Here let's provide it np.argmax and then the score. Now let's click on to this execute cell and see highest scorer is Sam only, so we are able to see Sam. Similarly, let's try it for the minimum score. So in that case, again let me use this print statement. There we need to pass this list which is students and then opening and closing of round parenthesis, and here we need to pass the index for the student who has scored minimum. So in that case, I will copy this particular expression which is np.argmin and then score, which is going to give us the index for the lowest mark. Let's provide it here, and now let's click on to execute cell and we should be able to see WishInfinite who has scored lowest. Let's click on to this execute cell and see we have got WishInfinite. And like this you can try it with multiple set of data. So usually argmax is used in every classification AI model. Now let's go to the next section, which is stacking, splitting and sorting, where we are going to talk about these concepts. Let's start with this stacking arrays. Here we are going to talk about two methods, which are vstack and hstack. Vstack combines arrays vertically on top of each other, and hstack combines them horizontally side by side, used when merging multiple data sets together. Let's see the practical example. Let's go to VS Code, and here let's add a markdown where we will mention the heading. So for that I will put 4 hashes and then this particular heading, which is stacking, splitting and sorting. Let's stop editing, and now let's add one more new code cell. And here first we are going to talk about stacking arrays. So for that I will take example of two one-dimensional array. If you want, you can also take example of two-dimensional array. So here I will give the array name as a equals to np.array and then opening and closing of round parenthesis, then square brackets, and here I will put values like 1, 2, 3. Similarly, let's create copy of this array where we are going to give value as b, and here we will put values like 4, 5, 6. So both are one-dimensional array. Now let's first use vstack, which will stack arrays on top of each other vertically. So for that we need to use this np dot and the method name is vstack, which is this one, and then opening and closing of round parenthesis, and here we need to provide this opening and closing of square brackets, and here we need to pass two items. So here for vstack we are passing one argument which is a list. So here let's pass these two arrays which are a, b. Right, so this list is containing these two items. Do not consider them as the separate arguments, right? It is a single argument which is a list where we are passing two items, which is our first array and the second array. Now let's save it inside one variable. So v equals to any name you can give here, and now let's print its value. So print and then v. So we are printing output which we are getting from this vstack, where we are passing a list as the argument which is having two items, which is our first array and second array. Now let's click on to this execute cell and see we have got our 2D array. Each one-dimensional array is stacked on top of each other vertically. So here first row is this A array and second row is this B array 4, 5, 6. And I told you that you can try the same thing with the two-dimensional and three-dimensional array. Now we saw that how vstack works. Now let's see how hstack works. So we will take example of these two arrays only, but here rather than using vstack we would be using hstack. So here let's create one variable h equals to, we are going to provide np.hstack this time, and then opening and closing of round parenthesis for this function, and here also we are going to pass one argument only, which will be a list, and this list would be containing two items, which is our array 1 and array 2. So a, b. A is containing our first array and b is containing our second array. Both are one-dimensional array for this particular example. Now let's print value of this h. So print and then h. This h is containing output of this hstack. So now this time it is going to place these two arrays side by side horizontally. Now let's click on to this execute cell and see we have got 1, 2, 3 and then 4, 5, 6. It is still one-dimensional array, but both the arrays stacked side by side. And as I told you, you need to try the same thing with the 2D arrays and 3D arrays. That is your assignment. You try it and just let me know into the comments that how it went, what kind of output you saw. In case of any doubts, just leave a comment under the comment section. Apart from vstack and hstack, we are also having one more function. Let's see that quickly. It is very similar. It is going to just do a general concatenation. So here I will give the variable name as c equals to and then np dot concatenate. And after concatenate, opening and closing of round parenthesis. And here again we are going to pass one list which is going to have two items, which is our array 1. Here in this case array 1 is A, then comma B, which is our second item of this list. Now let's print value of this concatenate output. So print and then opening and closing of round parenthesis and then C. And now it is just going to do the general concatenation, and there we are going to see 1, 2, 3, 4, 5, 6 in a row. Let's click on to the execute cell and see we have got this particular output. And as I told you, you need to try these functions with 2-dimensional array at least. And if you are curious, try them with a 3-dimensional array also. Now let's see the next concept, which is splitting. Let me put comma here. Here I will add one more code cell. And here we are going to talk about splitting. For the first one, we talked about stacking. Let me copy this also and put it here as the comment. So this particular code cell is for stacking concept. Now here we are going to talk about splitting concept. So for splitting an array, we are going to use this split method. This np.split divides an array into multiple parts at the specified positions. This is the same concept used to split datasets into training, validation, and test sets in machine learning. If you are not getting these terms like dataset, training, validation, test sets, and machine learning, so you need not to be worried about that for now. For now, you need to focus on to this splitting arrays, and for that we are going to use method which is split. Now let's go to the VS Code and see the practical example. Here let's hit enter, and now let's create one long array. We would be taking an example of one-dimensional array only, but you can try it with a two-dimensional array also. Now let's create one array. So arr equals to np, and this time rather than using array function, we would be using arange function. So np dot arange, and then opening and closing of round parenthesis, and here we are going to provide start and stop value. The first element of the array would be 1, and here we are putting 13. So the last element of the array would be 12, which is this 13 minus 1. Right? This particular number will not get included into array. I repeat this every time so that you do not get confused. Now if you will print value of this arr, what you will get? You will get one-dimensional array where you would be having numbers from 1 to 12. Let's do that quickly. So print. Now let's see the output here. See, we have got one-dimensional array where we are having values from 1 to 12. Now let's split this array into 3 parts. So for that we are going to use this split function. Let's see how to do that. So here we are going to use this np dot split is the function name, then opening and closing of round parenthesis, and here we need to provide two arguments. First argument would be name of the array or array itself. So here this arr is containing this array, so let's provide it arr, and the second argument would be the parts, that into how many parts we want to split an array. Here we want to split this array into 3 parts, so here let's provide comma, and here let's give second argument as 3. Now let's save it inside one variable. Here I will give variable name as parts, then equals to. Now let's print value of this parts. So print and then parts. What is parts? Part is a variable which is containing output of this split function, where we have passed this one-dimensional array and then the count that how many times we want to split this main array. Now let's click onto this execute cell and let's see the output. And see, it is creating a two-dimensional array where it has splitted this particular one-dimensional array and created 3 different rows. First row is containing 1, 2, 3, 4. Second row is containing 5, 6, 7, 8. And third row is containing 9, 10, 11, 12. We can fetch these rows one by one also. For that we will have to use this print statement and then this variable name which is parts, which is containing output of this split function, and then we need to provide the index here. So opening and closing of square brackets, and let's provide index as 0, which is going to give us this 0th row, which should have 1, 2, 3, 4. Let's see the output. See, we have got just one row which is containing 1, 2, 3, 4. Similarly, we can also fetch values of this second row. Let's do that. Let's copy this print statement where we are providing these parts, and this time we will be providing index as 1. So we will see the output at this first index, which is our second row. Now let's click onto this execute cell and see we have got 5, 6, 7, 8, which is our second row. And similarly, we can do the same for the row at the second index, which is at the third position. So here let's provide index as 2. Your index number would be always position -1. Let's click onto this execute cell. And here we have got our third row, which is containing 9, 10, 11, 12. Now here we have split the array into 3 parts. But what if we want to split at the specific index position? Let's do that also. So for that we need to use this np.split function only. And here we need to provide opening and closing of round parentheses, where first argument would be the array name, which is arr, this array, right? Which is having values from 1 to 12. Then we need to pass the second argument. So here we need to put this comma, space, and then what would be the second argument? So till now we were providing the second arguments, which was number of parts, that into how many parts we want to divide an array. But this time when we want to split an array at the specific index position, so in this case we would be passing the second argument, and here second argument is list, where we are going to pass the index number that at what position we want to split an array. So let's say we want to split this array at this 8th index, which is containing 9, and again we want to split the array at the 10th position, which is containing this 11. So how to do that? So in that case you just need to simply provide the index number here. So we want to split the array at the 8th index, so we provide 8 here. After that we want to split the array at the 10th index, so after comma we can provide 10 here. So we are providing a list which is containing the index number that where we want to split the array. So now what will happen? So this is our main array which is containing numbers from 1 to 12. Here we are providing that we want to split array at index number 8. So from this particular point we want to split the array. So inside first array what we would be getting? We will be getting values from 1 to 8, right? This same index will not get included. Similarly, we are also putting a split at the 10th index. So this is 8, then 9 and 10. So here we are also doing one more split. So now what we will get? First part would be having 1 to 8, and now it got splitted at this particular point till this particular point, right? 10th index is having 11. So now we will get one more array where we will get 9 and 10. And here as a split is happening at this particular point, we will be getting third array which would be having 11 and 12. And like this you can try to change index number and try to see the output. And here rather than taking the output into one variable, we can do one more thing. We can directly collect these parts into separate variables. So here we can provide a, comma, b, comma, c equals to. So directly we would be getting our first part into this a, second part into the b, and third part into c. Let's print value of a, b and c. So print a. Similarly we will also print b and c. Here I will provide b, and then next I will provide c. Now let's click onto this execute cell and we will see 3 outputs. You can ignore this part. If you want, you can also comment out this part so that you see the clear output. For now I will just execute this particular cell and see we have got 3 arrays here, where first array is having numbers from 1 to 8, which is our 7th index, right? Because at the 8th index we did a split. And now second array is having 9 and 10 because we did our second split at 10th index at this particular point. So we have got 9 and 10. And in the third array we have got 11 and 12. And this is exactly how you split a dataset into train, validation, test sets before training an ML model. Same concepts, real AI workflow. Now let's see the next concept, which is sorting. So for sorting an array, we are going to use this sort function. This np.sort returns a sorted copy of an array, and this np.argsort returns the indices that would sort it. Useful for ranking and ordering data. Let's see the practical example so that you will get more idea. Let's go to VS Code. Here, let me add one more code cell. Here, let me provide this command, which is sorting. Hit enter. Now let's create one one-dimensional array. So here we will provide arr equals to, and then np.array is the function name I am using to create a array. Now here we need to provide opening and closing of round parentheses and then square brackets. And here I will provide some random numbers inside this list, so that numbers are not sorted, and we will sort it. And we will sort it and see how output is appearing. Now let's provide some numbers here like 3, 1, 4, 1 again, 5, 9, comma 2, comma 6, comma 10, comma 17, and like this you can put any numbers here. Now you'll see here that these numbers are not sorted. After 3, 1 is appearing, then 4 is appearing, then again 1, 5, 9, and like this some random numbers are appearing here. Now how to sort it? So for that, as I told, we are going to use sort function. Let's use that. So to use that, we need to provide np dot sort, and here we need to pass one argument which would be our array which we want to sort. So let's provide this arr here. Now let's save it inside one variable. I will give the variable name as assay, which is for sort array. Now let's print value of this assay. You can give any variable name here, right? Assay, assay1, sorted array, or anything, right? I'm just providing little sort name. Now let's provide assay here, the same name where we have put sorted array. Now let's click onto this execute cell and see we have got the output which is sorted. We are first getting this 1, then 2, 3, 4, 5, 6, 9, 10, 17, right? From a smaller number to larger number. Now let's see the next function, which is arg sort. So for that we need to provide this np dot arg sort, this one. You can mouse over on it and see more details about this particular function. It returns the indices that would sort an array. Now here we need to provide the array. So directly provide arr, which is our this main non-sorted array. Now let's save the output inside one variable. Let's give the variable name as x, then equals to. Now let's print value of this x and see the output. So print and then x. Now let's click onto this execute cell. And this time we did not get a sorted array. We got the indices that would sort it. What does that mean? So here if you will closely look, here this first one is there at first index. So we got this first index. After that, this second one, right, which is our sorted array. So this second one is appearing at the third index. So we have got this third index here. After that, we were having 2 into the sorted array, and this 2 is there at the sixth index. So we have got 6 here. After that, we have 3 into the sorted array, which is at 0th index. So we got 0 here. And like this, we are getting index number for all the sorted items. We can use these index number to create one more array, or we can use this index number to fetch the value into the sorted order. So in short, this arg sort is just returning indices that would sort an array. Similarly, we can also sort a 2-dimensional array. Let's see that. Let's create one 2-dimensional array. Here I will give the array name as matrix only. Then equals to np.array, opening and closing of round parentheses, square brackets, and here let's provide first row, which will be having some random numbers like 3, 1, 2. Now provide comma after first row, then again second row where we will provide some numbers like 6, 4, 5. If you want, you can create one more row. Let's say put comma here, and here we will put some numbers like 9, 3, 8. This is a third row. We need to keep it inside one list and not provide it directly like this. Now we are having our 2-dimensional array, which is having 3 rows which are containing these numbers, but these numbers are not into sorted order. So how to sort it? So we can sort 2D arrays along axis. How to provide this axis value? Let's see that. So here we need to use this np.sort to sort an array, and then opening and closing of round parentheses, and here this time we are going to pass 2 arguments. Previously we were just passing one argument, but this time we need to pass 2 arguments. First argument would be our array, so this variable name which is containing our 2-dimensional array, and then we need to put comma, and after that we need to provide the axis value. So for that we need to provide this axis equals to, and as I previously also told you, that axis 0 is for columns and axis 1 is for rows. So let's provide axis 1. So now what will happen? It will sort out this particular 2-dimensional array, but based on the rows. So it will sort each and every row one by one. So for first row, we should be able to see sorted value like 1, then 2 and 3. For the second row, we should have 4, then 5, then 6. And for the third row, we should be able to see 3, then 8, then 9. Let's see the output. Let's save it inside one variable. Here I will give variable name as sorted matrix. So sorted underscore matrix, then equals to. Now we will print this value. So print function, and then this sorted matrix variable which is containing our sorted 2-dimensional array based on the rows. Now let's click on to this execute cell and see we have got our new output, which is a two-dimensional array, and here each row is sorted now. For first row we have got 1, 2, 3. For the second row we have got 4, 5, 6, and for the third row we have got 3, then 8, and then 9. Right? So first we are getting smallest number into the row, and then gradually it will increase. And similarly you can also sort it based on the columns. For that you have to just provide x is equals to 0. So it will sort this particular matrix on the column basis. So this time what will happen? We will get 3, 6, 9, then 1, 3, 4, and then 2, 5, 8. Let's click onto this execute cell and see we have got 3, then 6, 9. Here it is already sorted. Here it has to sort because we were having 1, 4, 3, but now we have got 1, then 3, then 4. And this third row is also sort. So we have got 2, 5, 8. And like this, you can either sort your two-dimensional array based on the rows or based on the columns. So for sorting based on the rows, you need to provide axis as 1, and for sorting based on the column, you need to provide axis as 0. I will comment out, but you can use any of them as per your requirements. So now we know how to sort our array. Now let's talk about one more concept, which is unique values. For that we are going to use this unique function. This np.unique returns the unique elements of an array and optionally their counts. Useful for understanding the distribution of categories in a dataset. If you are not getting this particular line, so it is very specific to the AI, you can just leave it for now. For now you need to focus that to receive the unique values of an array, you need to use this unique function. Now let's see the practical example. Let's go to VS Code and here let's add one more code cell. Here I will give this command which is unique values. I am providing these commands so that it would be easy for you to track the code. Now let's create one array. So for that we need to provide array name. Here I am providing arr equals to and then np.array, then round parenthesis, square brackets, and here let's provide some random values, and we will provide some such values so that this particular array is not containing unique values. Here I will provide 1, 2, 2 again, right? Then 3, 3, 3, 4, 5, again 4, 5. Now let's get unique values from this particular array, which is having duplicate values. Like here, we have 2 times, we have 3 times, we have 4 2 times, we have 5 2 times. So now we want to get an array which is having only unique values. So how to do that? For that we need to use this unique function. Let's see how to use that. So here we need to provide np.unique is the function name, this one, and here we need to pass one argument which is our array. So this arr we will provide here. Now let's print it inside one variable so that we would be able to see the output directly. If you want, you can save it inside one variable and then can print it. So let's provide print here, opening and closing of round parenthesis, and here let's provide this np.unique, which is accepting one argument which is our array. So now this unique function should return us one new array which will be having unique values. So these duplicate values will get removed. Now let's click on to this execute cell and see we have got 1, 2, 3, 4, 5. Because this 2 was duplicate, so we are able to see it only one time. This 3 was duplicate, we are able to see it only one time. Similarly, this 4 was duplicate, which was appearing 2 times. So we are getting this 4 only one time, and same is the case for 5. Now similarly, there can be one more scenario that we want to get these unique values as well as how many times these values are appearing. So here we will be using the same array only. So how to get the unique values and then their count also. So for that again we need to use this np.unique is the function name which we are going to use, and then opening and closing of round parenthesis. Here first argument which we need to pass would be our array, which is array in this case. You can provide any name, any array directly also you can provide here, and then we need to pass the second argument for this unique function, and this second argument's value will be Boolean. So the parameter name is return_count. Let's provide that here, and now its value would be true. So equals to and then true. How we are providing these arguments like this. So while learning about the functions, we have already seen that we can also provide the argument name and then its value. If you have not watched function related video, I would highly recommend you to watch that video so that you have clearer concept about functions. For now, you can see it like this, that we are passing two arguments. First argument is this array itself, and the second argument would be a Boolean value where we are passing value for this return_count. Here we are getting this error because here we need to pass this T as capital. So capital TRUE. Python is case sensitive, so you need to be very careful. Here we need to provide true where T is capital. And here, as I told, we are trying to get unique values and then that how many times they are there into the main array. So now we can save those values inside one variable. So here first we are getting values. So I will provide values as the variable name or vals, then comma, and then second thing which we are getting is count. So let's provide count here and then equals to. So this unique function is going to return us two arrays. First array would be having all the values, right, like this. So we would be able to see 1, 2, 3, 4, 5, right, all the unique values. And then second array, which is this count. So it will be an array which will show the output that how many times these unique values were there. So for this number 1, it will show 1. For this number 2, the count was 2, right? This item was available 2 times. Similarly, for the 3, we would be getting 3. For the 4, we would be getting 2 because this 4 is available 2 times. And for the 5 also, we would be getting 2. Now let's print value of this vals and count. You can give any variable name here, right? V or C or values or counts, whatever you want to give, it should be meaningful. Now let's print value of this vals and count. So print vals. And similarly, let's print count. So print and then count. Now let's click on to this execute cell. And here we have got an error for this particular line. Let's see what is the error. I'm not cutting this part so that you will get to know that how you need to read the errors and how you can resolve it. So here see, it is showing that we are getting error at line number 7, and here you would be able to see error also that unique got an unexpected keyword argument return underscore count. It is also showing us that did you mean return underscore counts. So that's what our mistake. We provided return underscore count, but here we should have provided return underscore counts. This one, right? Return underscore counts and then equals to, and after that we need to pass a boolean value, true or false. So here we are passing true because we want to see the count also for these unique values. Now let's click on to this execute cell again and see we have got two outputs, these two, right, 1 and 2, this one. So this output is containing all the values which are unique, like 1, 2, 3, 4, 5. Here we have provided 1, 2, 3, 4, 5. They can be 10, 20 or any number. It can be number, it can be float. And we have got second array which is containing count of these unique values. So this 1 was there only 1 time, so we have got 1. This 2 was there 2 times, so we have got 2. This 3 was there 3 times, so we have got 3. This 4 was there 2 times, so we have got 2 here. And similarly for the 5, it was there for 2 times, so we have got 2. So like this, you can generate array of unique values. Also, you can get count of those unique values. Now let's go to the next concept, which is reading data from files. For that, we are going to use this method, which is genfromtxt. So this genfromtxt is a NumPy function that reads data from the text or CSV file and converts it into NumPy array. It is one of the simplest way to load real-world data into Python for analysis. Now let's see the practical example. Let's go to VS Code. And here we will create one text or CSV file. You can create any file. For now, I will create one CSV file. So right click, new file, and the file name I will give as data.csv is the extension. Hit enter, and here we can put some values. Let's put some numbers separated by comma. You can put numbers separated by semicolon or hyphen. Any delimiter we can provide. Delimiter means the symbol which is separating numerical values. Let's provide some random numbers here, like 3, 5, 1, 7, 10, 30, 11, 44, or any numbers you can provide here, right? I'm just providing some random numbers. You can also provide some float numbers like 8.8, 9.9. And now let's save it. Now we want to read this data from data.csv, and for that we would be using NumPy function, which is genfromtxt. Let's see how to use that. Just let me add one heading. For that, double hash, and then this particular heading, which is reading data from files. It can be text file, it can be CSV file. Let's stop editing. Now let me add one more code cell. So here let's click onto this code. Now here what we need to do, we need to use this np.genfromtxt. This is our function name. And then opening and closing of round parenthesis. And here we can pass multiple arguments. Our first argument would be our data file. So how to provide that? So our data file is there into the same location, right? Into this same project. So what we can do, we can just simply provide data, which is our file name, dot its extension, which is CSV. If it is text, you need to provide TXT here, right? So the same name and extension you will have to provide as the first argument for this genfromtxt. Now we need to provide the second argument, which is for the delimiter. So what is delimiter? So delimiter is the symbol which is separating these numerical values. So here in this case it is comma, because we are separating different numbers using these commas. In your case it can be semicolon, it can be hyphen, it's up to you. So it depends on the data. In this case it is comma. Now let's go to this code, and here we need to provide delimiter value, which is our second argument. So for that we need to provide comma, and here we need to provide the parameter name, which is delimiter, and it should be exactly like this, right? Here you cannot make the change for this parameter name because it is already defined for the specific function. So let's provide delimiter here equals to, and then your delimiter value. In this case, as I told you, it is comma, so you need to provide it as the string. We need to use quotes, it can be single quotes or double quotes, and here we need to pass the delimiter, which is comma. Now let's save the output of this genfromtxt inside one variable. So here I will give the variable name as data1, then equals to. You can give any variable name here. Now let's print value of this data. So print and then data1. Now let's click on to this execute cell. And see, we are able to see the output, which is an array which is containing all the values. So whatever the values which were there inside this data.csv, we are able to see them inside this particular array. And like this, you can read any of the text or CSV file. It can be any long, but if you will read it like this by using this genfromtxt, you will be getting a new array where you would be having all the values which were there inside your data file. Now here we have provided this delimiter as the second argument. Apart from that, there are some more optional arguments. What is the use of that? We will be seeing that. So there can be one case that you are having your data file where you are having first row as the header and then you are having your data. Let me create a new file just to show you this example. I will create a new file here. I will give the file name as data_header, or with header we can write. So with_header.csv, or if you want you can write it as the text one also. I am providing CSV only here. Now let's create some data where we would be having first row as the header. So here let's give first row as num1, num2, or let's provide semicolon this time as the delimiter. So num1 semicolon num2 semicolon num3 semicolon num4 semicolon num5. And like this, there can be any large data. There can be multiple rows, right? Previously we have just created single row of data, but there can be multiple rows also. And now let's provide some data. Let's provide some number like 23 semicolon 45 semicolon 67 semicolon 55 semicolon 77. Any numbers we can provide, or any numbers can be there inside these data files, right? Practically you would not be creating these data files. You will be just reading these data files. Now let's read data from this particular data file where we want to skip this header row. So we don't want to read these headers. Now let's go to our code, and here inside the same code cell only, I will use this np.genfromtxt, then opening and closing of round parenthesis, and here first argument would be our data file with the extension. So our file name is data with header.csv. Let me copy it rather than writing it again. There can be spelling mistake, so that's why I'm copying it. So file name .csv. Now we need to provide the second argument, which is delimiter. So delimiter, careful with this parameter name. So delimiter, and here its value is semicolon this time. This one, right? This is the delimiter. So for the third argument, we need to provide comma, and here the parameter name would be skip_header. So skip, automatically it is suggesting us, so skip_header, and here to skip the header we can provide one here. And now let's save it inside one variable. So data2 equals to. Now let's print value of this data2. So print and then data2. Now let's click on to this execute cell. So here this print data1 is printing data from the first data.csv. And then this print data2 is printing value from this data with header.csv, where we were having this 23, 45, 67, 55 and 77. We wanted to skip this header, so it got skipped, right? We are not able to see it inside this array. Just let me quickly remove it just to show you what will happen if we are not skipping the header. Let me cut it. Now let's click on to this execute cell. And see, here it is reading it as nan, which is not a number, because it is a string, right? And we don't want it to read this string. So usually whenever you would be having a CSV file, you would be having one header and you don't want to read that particular header. So in that case, you can simply provide this argument, which is skip header equal to 1. Now let me again execute it and see, we have got all the numbers from this particular file. And now there can be one more scenario which you should be aware about, where you are missing some values. Let me first create a data file for that, and then you will be able to get the scenario. So right click, new file. Here I will give file name as data3,csv. Hit enter. You can give any meaningful name for these files. Usually you would be getting these files and then you would be reading these data. For now, I am manually creating this file just to make you understand this particular concept. Now here let's provide some values. Here let's provide one header, because usually into the CSV file you would be getting one header. So num1, comma, num2, comma, num3, comma, num4, comma, num5, comma, num6, comma, num7. And like this you can have multiple of columns, right? These are columns. This is our first row and here we are having these columns. You can understand it like this. Now hit enter. Now here let's put some values, which would be number. So 23, comma, 45, comma, and here I am missing one value. I am not providing any number here. So they can be the case, right? You are having CSV file, but there are some of the values which are missing. So it is separated by comma, but it is missing, right? There is no value for num3. And now let's provide some more values like 86, comma, I am providing some numbers, right? So we need to provide 7 numbers, right? num7 it is 1, 2, 3, 4, 5, 6, and this is 7th number. And like this, you can provide multiple rows also, as I told you. Let's see that example also. So here again, I will provide some numbers like 1, 2, 3, comma. Here I am missing num4. So directly I am providing comma, then 5, 6, 7. And like this, there can be any data. In this first row, num3 is missing. In the second row, num4 is missing. Now let's save it. Let's go to VS Code. And here let's read this particular CSV file and see the output. For that, I will create one variable name which is data3 equals to, and then np.genfromtxt, then opening and closing of round parenthesis. And here we need to provide the file name which is data3.csv. Whatever the file name which is there, we need to provide the same name. Then let's provide the delimiter. So comma, and then delimiter is our parameter name. In such cases where we are providing this parameter name and its value, this order of the arguments do not matter. But for now we are keeping this delimiter at the second position, so that's okay. And here delimiter is comma, right? We have created this file where values are separated by commas. Now let's provide third argument where we want to skip the header, right? These header values are not number, and in short we want to skip the header. So for that we need to provide this parameter name which is skip header equals to, and its value will be 1 if we want to skip header. Now again we will provide one more argument, and what that argument is for. So if your file has missing values, so in that case we want to fill it with some filler. It can be any number. Let's see that. So let's provide this parameter name. Parameter name would be filling values, which is this one, filling underscore values. Exactly same name you need to provide here. If there would be any error, which we previously saw that we were getting error for this return counts because we provided return count. So in that case you will be getting error, you'll have to correct it, right? So here what does this filling values means? So we are saying that into our data, if any of the value is not there, So in that case, we need to fill it with some value. Here you can provide any value. Here I want to fill it with 0. So on the place of these missing values, we would be getting 0. That's it. Here if you will mouse over, you would be able to see the set of values to be used as default when the data are missing. So in case of missing data, we are providing this value that we want to put 0 in case of missing data. Now let's print value of this data 3. So print and then whatever the variable name which we have given here. So data 3 here we need to provide. There is no relationship between this variable name and then this file name, right? Here I've given the same name. Here we were using some different name for these variables. So don't get confused. Now let's click on to this execute cell and see we have got the output, which is a 2D array which are containing these numbers. So here we have got 23, 45 and then this num3 was missing. So on this place we have got 0. After that it is showing 63, 86, 443 and 2. Similarly for the second row, so here inside this 2D array we have got one more row where we have got 1, 2, 3, 0, 5, 6, 7. Why 0 here? Because this particular value was missing. So on place of this missing value we have got 0. And why we have got 2D array? Because we were having multiple rows inside this particular file. For the previous files we were having single rows, so that's why it was generating a one-dimensional array. But in this case we are having multiple rows, so that's why it is generating 2D array where it is having multiple rows. Here if there would be 5 or 6 rows, so in that case you would be getting a 2D array which would be having 5 or 6 rows. That's it. Now there is one more concept which I wanted to cover here only. So as I told you that delimiter can be any value. It can be comma, it can be semicolon, right? Here it was comma, here it was semicolon, here also it was comma, and like this it can be any symbol. And also it can be spaces also. So these numbers can be separated by spaces. Let's create one file. So right click, new file, data underscore spaces or space dot txt. I'm giving the file name. Here I've given file name as data hyphen space, so that's okay, right? We'll have to give the same file name dot txt. It is not necessary that you will be getting files with this underscore in between, right? It can be any file name. So now let's use this particular file. Here we will provide some data. Let's directly provide some data. So 23 space 56 space, and like this I'm putting some numbers here. So here we are having multiple numbers which are separated by space. TXT file I've created, it can be CSV file also. I just wanted to cover example of this .txt file also, so that's why I've created this file with that txt extension. If you want, you can create it with this .csv extension, where we will provide data separated by space. Usually the CSV file will have data separated by comma. That's why its name is CSV, comma separated values. So for now we are using this .txt file. Let's try to read this particular data where each number is separated with a delimiter which is space in this case. Let's go to this code and here let's provide this np.genfromtxt, and then first argument would be the file name. Let's copy this file name, right click, rename, and then copy this full name. Here we need to provide it as the first argument, which would be string. And now here I want to provide one more argument which is delimiter. So put comma and then parameter name is delimiter. Delimiter equals to, and here in this case delimiter is space. So here we need to provide this delimiter as the string only. So you can use single quotes or double quotes, and here we just need to provide one space. That's it. Here I don't want to skip header or fill any values, so I am not providing those arguments here. Right, those are optional arguments. Now let's save it inside one variable which is data4 equals to. Now let's print value of this data4. So print and then data4, and let's execute it and see we have got this data. We are also printing these data, so that's why we are seeing different outputs here, but we need to focus on to this one where we are getting this 25, 56, 87, the same data which we have put inside this data-space.txt. Here there can be any file name, and see we have got this 25, 56, 87 till this 3 and 7. See, every time whenever we are reading data from the CSV and TXT file using this genfromtxt, So it is converting that number into float. So you need not to be worried about that. We are just able to read that data and we are able to use this data. And here we have just seen some of the arguments like delimiter, skip header, filling values, and like this there are multiple arguments. If you mouse over onto this genfromtxt, here you would be able to see multiple details related to this particular genfromtxt function. See, as here you can see, we saw this delimiter, skip header. Similarly, we have this skip footer. Here if you will scroll down, you would be able to see more details related to these parameters. So you can go through these particular details, and if you want to pass the specific option, so that you can pass as the argument with its values. For now, for you, these many options are more than enough. But for your practice and for your knowledge, if you want to see more options which you can pass as the argument for those parameters, so you can put that here and see what is happening. And as I told you, we can perform any operations onto this data which we are reading from these text.csv files, so that you can try, right? Let's say we want to get shape of the data which we have loaded from the text.csv file. So that we can do, let's see that quickly. So let's print shape of this data 3, which was our 2D array, right? This data. So in that case, what we can do, we can provide data3 dot shape. Click onto this execute cell and see we have got 2,7 because it is having 2 rows, which are these 2 rows and 7 columns. See 1, 2, 3, 4, 5, 6, 7. See here also you can see we were having columns from num1 to num7, 7 columns. Similarly, let's get data type of this loaded data. So for that I will give this print statement or print function, and then data3 or any data which we have loaded, we can use that. So data2 dot dtype. Let's execute it and see we have got its data type, which is float 64. As we are able to see it here also that we are getting float numbers and not the integer number. And the same is getting reflected here by using this dtype. And this is just an example. We can perform any of the operation or fetch any of the details for these arrays. So we can perform any of the operation which we just saw, like indexing, slicing, array operation, reshaping, transpose, or any other operation, right? I'm just giving you an example. So you can load the data, and onto that loaded data, which is an array only, it can be one dimensional or two dimensional, we can perform any of the operation. And here for simple numeric data files, this genfromtxt function is perfect. But for more complex data sets with mixed data types like names and numbers together, you will use pandas, which is exactly what we are covering in the next video. And guys, if you're finding this AI engineering course helpful, let me know into the comment section below. And feel free to share your suggestions. I would love to hear your thoughts. And now I will conclude this video here. But before we wrap up, let me give you a quick recap. So here we saw that what is NumPy. So it is a Python library which provides a powerful array objects. How to install the NumPy? For that, you just need to give the command which is pip install and then NumPy. And then to use it, we just need to give import NumPy as np. And here we also saw that what are all the advantages of NumPy over the Python lists. So NumPy is faster, it uses less memory, it supports element-wise operations directly. This NumPy arrays can hold only one data type, so calculation would be more faster. NumPy provides multiple mathematical functions, and NumPy also provides supports for 2-dimensional and 3-dimensional arrays. And like this, there are so many benefits of using NumPy over Python lists that we have already seen, right? There are so many functions which we can use. Now after that, we saw multiple concepts, and for that let me go to the VS Code, and there only I would be able to show this concept. So here first we imported this NumPy as np. np is alias name. Then we saw that how to create an array. So for that we have used this np.array function where we can provide the list to create an array. Similarly, we can provide 2-dimensional array where we will provide array inside array. So this 2-dimensional array would be containing multiple rows and multiple columns. And similarly, we saw that we can also create 3-dimensional array like this. After that, we saw different functions to create different type of arrays. Like we can use zeros to create array of zeros, and it will create array of zeros of that particular size. Similarly, we can also use this ones function, which will create array of ones. We can also create array of the specific number. For that, we are going to use this full function, where we can provide row comma column as a tuple, and then the number for which we want to create an array. And here remember, that when we are using the zeros, ones, full, so in this case we are not passing two arguments. We are passing one argument, which is a tuple where we are providing these items, row and column. And it is not mandatory you would be passing tuple only. For some places you would be providing different arguments. For some places you would be providing list, right? So you need not to remember it. You can simply search it into the Google or onto the AI assistants and you should be able to get details about it. Or just to keep it simple, you can just follow this particular tutorial and this particular code, right? I would be uploading the same code onto the Git repository. After that, we saw that we can use this I function, which will create an array, which will be having this diagonal value as 1. Here we have provided 3 as the argument, so it is creating an array of 3 rows and 3 columns. After that, we saw that we can use this arange function, which is going to give us an array. So here we need to provide the start and end point, and then we are going to get the output. So see, we have got an array which is starting from the 1 and ending at the 8, because this end number will not get included. We can also provide third argument here for this arange, which provide the step. So after 0 we have got 2, then 4, right? One step is getting missed and we are directly jumping on to the second step. After that, we also saw this linspace concept. This linspace will provide an array between these two numbers, and here we can provide this number that into how many equal parts we want to divide this particular array. So we wanted to generate the array between 1 to 20, where we want each value to have equal space from each other, and we wanted 6 values like this. So see, here we have got 1, 2, 3, 4, 5, 6. After that, we saw that we can use this random.rand function to generate an array of random numbers. Here we are providing 3, 5 means 3 rows and 5 columns. Similarly, we can use this random.randint, where it will generate a random array between these two numbers. Here I have provided 1 as the start number, 200 as the ending number. And then we are passing one more argument where the parameter name is size equals to, and its size's value is tuple, where we are passing two values, row and comma. So 4 rows and 7 columns. After that, we saw that we can use the seed. So this seed concept we would be using in combination with this random, where we provide this np.random.seed, and here we can provide any value. And after that, whenever you would be using this random.rand or randint function to generate an array of random numbers, so after first generation, it would be keeping those values as it is. So whatever you generate first time, every time you are going to get same output with those random values. So these random values will not get changed. Let me re-execute it again and see, these values are not getting changed. Every time we get the same output because we have used this seed and this number. So I gave you one example, right? You are having a book of random numbers. There are millions of random numbers. Now, onto each page, you are having some set of random numbers. And here, by using that seed, we are just providing that we want to take random numbers from this page number. It is not exactly like this, but just to make you understand this particular concept, I have given you the example of book. And now every time it is going to fetch random numbers from that page number 42 only, and we are not going to see any difference into the array which is getting generated with the random numbers. That's it. Now after that, we saw array properties, where we saw that for the array we can get its shape using this shape, we can get its dimension, we can get its size, we can get its data type using this dtype. See, this is a shape, it is providing row and columns, dimension is 2-dimensional, 3-dimensional, size is number of items, so it is having 6 values, and dtype is its data type. Then if you will scroll down, you would be able to see apart from this int64 there are multiple data types. Like here, if we are providing floats, so its data type would be float64. And here we are creating an array, but purposefully we are providing this dtype equals to float. So again, it will convert these integer value to the float64. And similarly, we can also provide this dtype equals to np.float32, where it will convert these numbers into float32. So by default, it converted into float64 only. So if we provide this float, it convert it into float64. But purposefully, if we want to convert it into float32, so we can provide it like this. So this float32 would be taking little less memory. Now let's scroll down, and here we saw about indexing and slicing, where we created an array, and there we saw that we can use index number to fetch the specific value of the array. We can also use negative indexing, and here we can use slicing. Like here we want to get the specific part of the array, where we have provided start position and the end position. One is the start position, means first index. So here we have got 20, then end position was 4, which means index is 4, which is for this 100. And this particular index will not get included in case of slicing. So we are getting values from index 1 till index 3. This end value minus 1. And we also saw that if we want to slice it from the 0th index till the end of the array, so in that case you need not to provide the starting index before this colon, so we can leave it blank. After this colon we need not to provide the ending index because our end value is till end of this particular array. Again we are providing this colon where we are providing the steps that we want to start from 0th index, right? And then we want to skip one step, directly we want to go on to this second step. So we have got this 10, then we skipped this 20, then we got 30, and similarly we have got 100. After that we saw the same concept for the 2D arrays where we need to provide indexing using rows and columns. So if we want to get second row and second column values, so second row and second column. When I'm saying second row, second column, it means I'm using this index numbers like 0th row, first row and second row, 0th column, first column and second column. You can either say it by indexing name or position name, it does not matter, but usually while fetching the value you are going to use index numbers. So it's better you call them verbally also with the index number like 0th row, first row, second row, 0th column, first column, second column. And do not get confused if someone is using position like first row, second row, third row. It is not mandatory to call it with the index number. Similarly, we saw that if we want to get complete rows, in that case we can provide row number here, comma, and column as the colon we can provide, which means from 0th index till end index of the array. Similarly, we can do it for the columns also, like we want to fetch complete column. So in that case, we are providing colon here, comma, and then first column. So for the first column, 2, 5, 8 we have got here. We also saw that we can slice a specific part of the array. Like here, from 0th index till second index, we want to get each row. And for the column also, we want to get from 0th index till second index. And this end value will not get included, which means from 0th index till first index for the row, and for the column also 0th index till first index. So that's why we have got this 2D array which is having 2 cross 2 matrix, 2 rows, 2 columns. After that we saw that we can also modify elements inside an array. So for that we can directly provide the array and then its index within square brackets and then new value. Like here we have added 99 at the first position. Similarly we can also replace the values in bulk. In that case we will have to provide this range which we used for the slicing from the index 1 to index 2. We want to replace it with 109. So see here this 2 and 3 got replaced with this 109. And similarly for the 2D array we can also change the value. Here we created this 2D array and then we changed value at 1, 1 index, which is this 5. We change this 5 to 555. First row, first column. Now after that we saw the Boolean indexing, where we can provide a specific condition and then we can see the output. Like here we were having this particular array, but from this array we just wanted to get all the numbers which are greater than 30. So we provided this particular array, then opening and closing of square brackets, and inside it we provided one condition, which was that from this particular array we want to get all the values which are greater than 30. So that's what we were able to see, right? That output we have got. Here we seen the example to print even numbers that you can try it at your end. Here we have used this mathematical operator which is modulus operator, and here we are just doing comparison that remainder after the division, if it is equals to 0, number is even. We also saw that we can also iterate through the NumPy array. For that we can use this for loop, and here we need to use simple for loop only. For x is the temporary variable in arr, and then we are printing value of this x. Similarly we can also iterate through the 2D array, where if we want to get each and every row we can just simply iterate through this 2D array. There with this temporary variable we will be getting each row one by one, and if we want to get each and every value we can use this nested for loop. So first we will be getting row. Row means we have got 1D array, and on to 1D array we are just simply again providing this for loop which will give us each and every value. But rather than using this nested for loop, you can also use this nditer concept. So this nditer is a function, so you need to use this for loop only. So for val in, then here we need to provide this np.nditer and our 2D array. So this time, rather than using this nested for loop, directly we would be getting each and every value when we use this nditer here. Now let's scroll down, and here we saw that we can also use this ndenumerate function, where with the value it will also provide us the index number. So see, here first it is providing index position, like for the 2D array we will be having row and comma values. So 0th row, 0th column value, which is 1. 0th row first column value is 2. So like this, if you want to get the index as well as value, so you can use ndenumerator rather than using nditer. How to use that we have already seen. You can see this particular concept, you can see this particular code and try it at your end. After that, we saw new section, which is array operations and math, where we saw that we can use these arithmetic operations which will get applied onto each and every value of an array. So see, here we have added this ARR plus 10, so 10 got added with each and every value. Similarly, we have done the multiplication, power, division, and this modulus, which will provide us remainder after the division from this number. Similarly, we saw that we can also perform the operation between two arrays. So here we were having these two arrays, and then we try to add those two arrays, multiply those two arrays, or divide these two arrays. So on the basis of index, it would be doing this particular operation between two arrays. So value at 0th index will get added with value at 0th index into the second array. Similarly, for the multiplication, it would be multiplying values at the same index. Then we saw this broadcasting concept, where we saw this example that if we are having this 2D array and 1D array, and if we are performing this mathematical operation onto them, so what will happen? So in case of this 2D array and 1D array addition, this particular row of one-dimensional array got added with each and every row of two-dimensional array. So see, 10 got added here, so we got 11, and similarly 10 got added for the second row, so we got 14, and same is case for this 20 and 30. So row of this one-dimensional array is getting added with each and every row of two-dimensional array. Now let's scroll down. After that, we saw these universal functions or mathematical function, where we saw that we can get square root, log, exponential, absolute value, sign value of each and every element of an array. Here we have done SVRT, so we have got square root of each and every number inside this particular array, and same is applicable for log, exponential, absolute, sin, sign, and like this there are multiple functions which you can use to perform mathematical operations. And here I have just taken an example of some mathematical or universal functions. Like this, there are multiple of mathematical functions which you can use. For that, you can simply Google it. Let's say if you want to perform a specific mathematical operation, or you can follow official NumPy documentation. For that, you can search for this NumPy documentation on Google or NumPy references. So you will be getting details related to these functions. Or just search NumPy functions. Now let's scroll down. After that, we saw this dot product, where if we use this dot product for two arrays, so what will happen? It will multiply elements between two arrays at the same index, and then it will add all of them. So that's why we have got 32, because it multiplied 4 by 1, 5 by 2, and 6 into 3, and then it added all the values. After that, we saw this matrix multiplication, where we can use this matmul function, which is for the matrix multiplication. So here we created these 2D arrays, and then we have used this np.matmul, where we passed these two arrays as the argument. And how this multiplication happens, that I've already told you. This is mathematical concept, where each row will get multiplied with each column. So here this first row will get multiplied with this first column, then this same first row will get multiplied with the second column, and for the second row also the same thing would be happening, and you will be able to see the output like this. What is matrix multiplication? That I've already explained with this simple example. Then we saw this reshape and transpose section, where we saw that we can use this reshape method to reshape a specific array. So here we were having one-dimensional array, but we have used this reshape function, where we have passed row and column values, so it generated 2D array from the 1D array, which was having 3 rows and 4 columns. And if you check shape also of the generated reshaped array, you would be able to see the new shape there, like this. From this one-dimensional array, it generated this two-dimensional array with 3 rows, 4 columns, and it provided its shape also as 3 rows and 4 columns. And if we are not sure about specific row or column value, so you can provide, let's say, row value and provide column value as -1, so automatically it will calculate. Because you need to make sure that you are covering all the elements. If there are 12 elements inside the 1D array, so you'll have to provide 3, 4 or 4, 3 or 6, 2. Otherwise, you will be getting error. Now let's scroll down. Now after this, we saw about this transpose, where it will convert rows into columns. So we were having this 2D array, but when we have used this .t here, so these rows got transposed into column. See, 1, 2, 3, here it was row, here it is column. Similarly, 4, 5, 6 was row, here it is column. Now after this, we saw this flatten and ravel, which converted our 2D array into 1D array. This flatten creates a copy, this ravel do not create a copy. But both are doing the same thing. Then we saw the next section, which is statistical functions, where we saw that we can use sum, mean, median, standard deviation, min, max function to get the specific output. When we would be learning about math, we would be seeing that what is mean, median, standard deviation. So if you are not aware about that now, so you need not to be worried about that, right? For now, you just should be aware that into NumPy there are such functions which can do such complex calculations also. See, here we have got sum, mean is average, then median is standard deviation, mean is the minimum value, max is the maximum value. And here we also saw that we can do all these calculation based on the axis. So let's say if it is a 2D array, so if this axis is 0, which means it is going to do all these calculation, whatever the function which we use, like sum, mean, median, std, min, max, on the basis of column. Axis 0 means do these calculation for each and every column. And if we are providing axis as 1, so we are saying that do these calculation onto each and every row. See, here we saw one simple example for the sum. So if axis is 0, it is adding 70 plus 40 plus 10, which is 120. And if the axis would be 1, it would be adding 10 plus 20 plus 30. Similarly, we saw the same example for the mean, max, and like this you can also try median, standard deviation, minimum. That's up to you, right? For your practice, you should try it. Now after that, we saw this argmin and argmax. And what this argmin and argmax do? So it provides the index number. This argmax provides the index number for the maximum value of the array. This argmin provides the index number for the minimum value of the array. And then we can use this index number at different places. Let's say we were having this particular list, and for this list only we created one array which was having a score for these students. So for now, let's say we wanted to fetch the student who scored maximum. So from here, by using this argmax onto this array, we got the index number for the highest score, and then we have used that particular index here to get the student name. Here we are directly able to see, right, that this is the maximum number, but when you would be having 100, 200, 1000 of scores there or thousands of number there, in that case these functions will be very helpful. And after this, we saw the concept related to this stacking, splitting and sorting. So for the stacking, we can use this vstack to stack two arrays vertically. This stack we can use to stack two arrays horizontally. And this concatenate can be used to concatenate two arrays. Then we talked about splitting, where we can split the array into multiple parts. For that, we need to use this split function, where we need to pass the array, and then in simple case we can pass number of parts, that into how many parts we want to split the array. Similarly, we can also provide the specific index number, that at what point we want to split an array. Like here we have splitted the array at the 8th index and at the 10th index, which means at this point we have splitted the array. So that's why we got output like this. So it splitted the array at this particular point. So our first array was having these many values. After that, we splitted the array at the 10th index, which is at this number 11. So our second array was having number 9 and 10. And our third array was having numbers like 11 and 12. After that, we saw that we can also use this sorting, where we can sort any array. So we were having this array, and when we have used sort function onto this one-dimensional array, so automatically it got sorted. First we got the smallest value, and then it got increased. We can also use this arg sort, which will give us the index number for the sorted array. Like this, for the 1, the index was 1. After that, for the second one, the index was 3. For this 2, index was 6. So we can also get index position of the sorted values. We also saw that we can also perform this sorting operation onto the 2D array, where we can provide access. If you will provide access as 0, so it will sort each and every column. If you will provide access as 1, it will sort each and every row. And then we saw that we can also use unique function. So let's say if you are having an array which is having duplicate values, so in that case you can use unique function, which will give you the array which will only be having the unique values. Like here we have got all the unique values inside this array. We can also calculate count for the duplicate values. So in that case you will have to use this np.unique function, but there you can pass one more argument where you can pass this parameter name, which is return underscore counts equals to 2, which will give us that how many times the specific number is getting repeated. So this 1 was there for 1 time, 2 was there 2 times, 3 was there 3 times, this 4 was there for 2 times, and 5 was there for 2 times. So that's what we saw here. And after that we saw that we can also read data from the text file or the CSV file. In that case we need to use this genfromtxt function, where you can pass first argument as the file name dot the extension name, and apart from that you can also pass delimiter, that what is your delimiter, which is separating multiple numerical values. We can also provide argument where we can skip the header. We can provide argument to fill the missing value by using this fling underscore values equals to any number which we want to fill. Similarly, we saw that our numbers can be separated by space. So in that case we can provide delimiter equals to space. And by using this genfromtxt, we would be able to read any of the data which is there inside the CSV or TXT file, and then we will be getting the output as the array. And now we can perform any operation onto the array by using any of the NumPy function, or we can fetch any of the property of that particular NumPy array. What are different type of properties? What are different type of functions and functionality which can be used with the NumPy that we have already seen? There are many more such functions or properties that you can use, but for now these many concepts are more than sufficient for our AI engineering course. And now it is not necessary that whatever the example which I've used, you need to use the same concept or same example. You can try to use 1-dimensional, 2-dimensional, 3-dimensional array to perform different operations or fetch different properties. Do your practice. In case of any doubt, just let me know into the comment section below. And for now, here's the thing. Everything we did today might look like we are just playing with numbers, but this is foundation of all AI. When a self-driving car processes a camera image, it is NumPy array. When ChatGPT processes text, it is eventually becoming array of numbers. When a doctor uses AI to detect cancer in X-ray, it is 2D NumPy array being analyzed. You have just learned the building block of all modern AI. This is not just a tutorial, this is the beginning of something big for you. And now that's it from my end. You can click onto this first card to go to the next video. You can click onto the second card to access this whole AI engineering course. And stay tuned for my upcoming videos. If you have any comments, questions or doubts, you can let me know into the comment section below. Please like, share and subscribe to my channel. Thank you very much. Have a great day.